So good evening. Tonight we're going to do an update on the Astronomy pan-tilt zoom surveillance camera adaptation. I attempted to do it live before we started, and I'm still fighting the infrared illumination, the autofocus, and the auto zoom. I've sent an email off to the manufacturer asking for a way to disable those so I can go ahead and write the drivers to control the camera, but as of yet they're not replying, so I'm gonna have to beat on them harder. But first, the news. Hey, Lucy finally got off the ground. Lucy is NASA's mission to go study the Trojan asteroids that are in the same orbital plane as Jupiter. Jupiter is officially a planet and not a dwarf planet, unlike Pluto, which is a dwarf planet because it has not cleaned out its orbital plane. Yeah, not a fan of the current definition of a planet and a dwarf planet and things like that. But it's going to take Lucy, I think, over a year to actually make it out to Jupiter. It's going to be doing a slingshot orbital assist and go out through the asteroid belt and pass one asteroid first, and then it'll go out to the Trojan asteroids. So Lucy's not really getting anywhere near Jupiter itself. So Lucy will slingshot between one set of the asteroids and another set of the asteroids that are in orbit with Jupiter. If you remember us talking about the Lagrange points, and there were L4 and L5 on opposite sides, that's where these Trojan asteroids are located. So Lucy will be pinging, will be doing a long elliptical orbit that takes her from one of the Trojan groupings to the other Trojan groupings and then back again.
I remember one other thing you had about Lucy that was interesting.
Lucy's named after the early hominid Lucy, which was named after Lucy in the Sky with Diamonds.
Yes, that was a good part.
Yeah.
I didn't want you to miss that one. That was good.
And Lucy is not an acronym, it's just a word.
A name.
Yeah. Now, if you'll notice, there's these large petal-shaped solar cell arrays. That's how Lucy is powered. They would have wanted to use radioisotope thermoelectric generators, RTGs, to produce the power, but there was this window of time where Congress was not allowing the U.S. Department of Energy to create any new plutonium because of agreements we had internationally to not make hydrogen bombs. So that stopped us from making plutonium. And then when everything fell apart during a certain administration and we violated all those treaties by saying, nope, I'm not obeying that anymore. There was a burst of plutonium that got created as quickly as possible. And that's why Perseverance has plutonium, Curiosity has plutonium. But this Lucy being later in the process, sorry, no plutonium for you. James Webb Space Telescope being earlier in the process, that's why it has solar arrays as well. But there are peacetime uses of radioactive materials. I won't say fission, because RTGs are not fission. All that happens is the plutonium slowly decays into lesser elements. And when it does that, it releases a continuous stream of about 400 degrees Fahrenheit heat. And then they run thermocouples through the plutonium core to convert the heat into electricity. And that's what powers Curiosity and Perseverance and probes like that. So it's not fusion and it's not fission, it's nuclear decay. So it's just a heat source. And the James Webb Space Telescope has officially arrived at the seaport at French Guiana for its launch in early December. Hey, it made it. The pirates didn't get it. You can't actually see it here. What you're seeing on top of this freighter is the support container cargo. The telescope itself was secured down underneath plates in the hold. They didn't want the billion-dollar telescope to accidentally get hit by anything. Now, it's inside of its own giant suitcase. So the suitcase would have protected it, but they didn't want to take any chances. It actually went from the California down through the Panama Canal over to French Guiana. So it'll be launching on December 18th, and we'll do our presentation event on the JWST on December 11th. That's a Saturday.
Hopefully.
Well, we're going to do our presentation event even if it doesn't go up on the 18th, even if something bad happens to it. We're still going to do the event. Okay. Once again, a Russian Soyuz capsule that was docked at the International Space Station, whoopsie, it accidentally turned on its reaction control thrusters and attempted to spin the International Space Station. What's the old saying? Trick me once, shame on the Russian Soyuz. Trick me twice. Oh, it's definitely the Russian Soyuz. Should they be allowed a third time? Shouldn't they have to turn everything off while they're docked? They were doing a pre-departure planning, and we'll get to what they were pre-departure planning for. They got to 57 degrees off axis. However, if you remember when they last pushed the ISS off axis, they originally said, don't worry about it. It was only 78 degrees. And then they came back later and said, oh, our bad. It was 720 degrees. So it actually spun it around. This time up front, they're saying, oh, it's only 57 degrees. I'm sure they'll come back later and go, oh, our bad. It was 570 degrees. My concern is this the Russians attempting to like fracture the International Space Station so they can back out of their agreement to be there? Why don't they just, say, we don't want to be there anymore for you because we don't like you as much as we used to. And you're not paying us $1 billion a year to launch your NASA astronauts to the space station. So we don't want to be there. That would be fine. I hear the Chinese have a lovely new space station. And speaking of that, the Chinese space station was not unoccupied for very long before they sent up another 3-person crew for a 6-month stint at the space station. And you can see that while it's only 2 modules, it's nice and roomy. It's just, it's ISS size roomy on the inside. Nice space station. This is not the first woman Chinese astronaut. This is the first woman Chinese astronaut aboard the Chinese space station. And she will also be the first Chinese woman to do a spacewalk. So Virgin Galactic, after their last flight, this was another suborbital flight. If you remember, they ran into hot water with the FAA because they went off course. Well, they're upgrading some of their aerodynamic controls and some software, and it's going to push their next flight out until late in 2022. And because of this delay, the Virgin Galactic stock took like a 20% dip. I'm sure it'll recover, but that's the price you get for disappointing people nowadays is your stock goes into the dumper for a while.
Can I go back to the Russian-Chinese situation with the space station?
Sure. What do you want to know?
Well, I'm thinking about the fact that it's very good for the world when we got along up there in the space station, and it was the astronauts themselves that made it possible that they got along up there. And it was like an unusual situation that people could get along of different countries, and it was unique that was working. And I wonder if the astronauts still want it to work and it's just a political thing. And that's why they don't just come out and say, well, we don't want to be there, because the astronauts probably still want to work with all the other different countries.
From what I've read and what I understand of NASA and the astronauts and how they pick the personalities involved, yes, the astronauts definitely want to keep relationships good with all the nations of the ISS. And my guess is they would probably invite the Chinese to be there, but U.S. federal policy, I found, is what's stopping that.
Well, I heard some interviews of some of the American astronauts, and they always mention that they made friends for life. So I think like individually, they are co-workers and friends and living together in a tight space. You make friendship, you have no choice.
Yes.
But then like, I think publicly, they need to obey the bosses.
Yes. The ISS has had US, Russian, Japanese, European Union, Great Britain, I don't know how many other nations.
Brazilians?
Yes, they've
One
had a
Brazilian.
Brazilian on board. You know, just a number of nations, even if they didn't originally contribute in the building of the ISS, they found a way to get those nations involved in the programs such that they could have representation in the ISS, even if they weren't contributing, you know, many, many billions and, you know, actually contributing modules and such. But even within groups like the European Space Agency and the EU, individual countries produced and contributed their own modules. Italy produced a module that was used as sort of an outdoor patio onto which they could put astronomical instruments. It wasn't actually a sealed compartment. It was kind of a shelf on which you could mount external instruments. So as many nations as were willing to contribute in some way, they've been a part of the ISS, but it was US politics that said, China, you've got to do your own thing. Good luck on that. And then when the Chinese did one, they went, hey, we didn't think you were going to do that. And the Chinese went, why shouldn't we? We're an independent nation and you wouldn't let us play on your playground. China
well, like you said before, it wasn't a bad thing to have two of them up there in case one of them had
I think it's good to have more than one egg in the basket in case somebody drops the basket. But what it does allow is a little bit of competition to keep the ball rolling, which if you think about the initial space race between the US and the former USSR, that's what got us to the moon as fast as we did, is competition. And we've got to do one better. And that's why China has the newest, best looking, probably very well equipped space station. Is they put it up there last year. And our last module from the US that went up the space station, oh, that's right, next year we're going to bring up a new module. I guess that's to just say, see, we can still do it. Now the question is, who's going to launch that? Because they've stopped launching the United Launch Alliance Atlas Vs because the US Congress said you can't use any more of those Russian rocket engines. And Blue Origin has yet to classify their rocket engine that they said, oh, we can do that. So the Russian film crew with the Russian actress and the producer director and their cosmonaut that was sort of minding
Throw her up on a little bit.
I'd like to, but watch what happens. The ad stays up there.
Oh.
I can't make the ad. Oh, there it goes. Okay. But now you've lost the title. So here's the three smiling faces. Now, this is the Soyuz capsule that just the other day inadvertently fired its rocket engines and tried to twist the space station again. Now, obviously, it was neither the actress nor the producer director that was at the helm when that occurred. It was the Russian cosmonaut preparing it to depart. Yeah, you have to make sure that all your propulsion systems will work, but you're not supposed to fire them. Trick me once, shame on you. Trick me twice, shame on me. Trick me three times and the ISS could be ripped in half.
Well, there was an accident, right? They didn't mean to do it.
No, it was an accident the first time. What was it the second time? Yeah.
You don't think the accidents can happen twice?
Not when you're supposed to have taken action based upon the first accident. Like, okay, while we're docked, these particular systems left off. Turn them off. So there's no more accidents. But apparently, there was another accident.
But was it exactly same accident, or was it a different?
Yeah, no.
Oh, it was the same exact
no, it's exactly the same accident.
Wow.
So something's not smelling right.
Well, they didn't want to kill themselves, right?
Well, if they still are on the Soyuz, they won't be killed. The problem who's in the space station is going to fall apart.
Yes.
They wouldn't get killed?
No, because they were sealed in the Soyuz capsule.
Oh.
As part of this test maneuvering, they have to move the Soyuz capsule from one side of the space station to the other. But while they're docked, they're not supposed to have their thrusters enabled. They're not supposed to be turned on, let alone firing. And they were docked, the thrusters were enabled, and they turned them on.
So the accident is that they didn't blow up the space station.
It's not a matter of blowing it up, but it's a matter of snapping it like a pencil.
So they depending where the other astronauts are inside the space station, they wouldn't even have time to actually run
No.
to the other Soyuz and other.
Yeah, the
you know,
space station would
lifeboats.
be the space station would be evacuated of its atmosphere in a matter of seconds.
So there was a matter of luck there twice that it didn't happen.
Correct. But then afterwards, Russia was complaining, oh, the ISS, it's old, it's distressed metal, it's got cracks all over it. Yeah, if you would stop stressing it, there wouldn't be cracks. But funny enough, the cracks appear to be only in the Russian modules. Now, if you remember, the very first module of the International Space Station was actually a Russian module. So that's the oldest material that's up there, is the initial Russian module.
Was Veda, right?
Zarya?
Zarya.
Yeah. And in fact, if you look at the orbital elements for the International Space Station, they are identified by the satellite object of Zarya. So the ISS is actually identified by the first module, which is the Russian module.
So you really think that they wanted to damage the space station?
It's his opinion. They might.
You know, if it happened once and then never again, I would say completely an accident. But if it happens twice within the span of less than 6 months and it's the same issue, somebody's not doing something right. Or somebody's doing something knowingly wrong. I don't know which.
I wonder if they fired that astronaut. Was it the same astronaut?
No, it was not.
Probably mechanical problems.
The first time they said it was a mechanical problem. Then they came back later and said it was a software problem. So let's see what they say after this one, how they explain this one away. Okay.
It's horrible to think that they would want to kill people up there.
Well, they're not going to kill themselves because they're sealed in the capsule. All they have to do is just pull the manual release and the capsule would back away from the ISS. But there are 3 other Russian cosmonauts on board the ISS right now.
Wow.
I think now they should start doing like a procedures for when any spacecraft is docking, they should close
They should not only close the outer hatch, they should close the inner hatch.
All the hatches. Yeah.
No, you can't
like
do that.
Isolate people in places.
You can't do that because the long-term modules all have plumbing running through the hatches. So you can't close them.
That's a real problem then, because it's
well, it wouldn't be a problem if the Soyuz
place.
modules weren't having a problem.
Right, but it shows that there was a problem.
Yes, they need to fix their problem. NASA can't fix the Russians' problem.
That's right.
Yeah.
That's the problem.
Yes,
if
that's
we
the
could
problem.
fix it, that wouldn't be such a problem then.
Right,
Like,
but they're not.
Helen's trying to think of ideas so if they do it, again, we would be able to deal with it. We've been lucky, as you're pointing out, but we want to be more than lucky.
Yes.
It's space.
NASA has policies that will prevent these things from repeating. When you have a problem, you go through what is known as a risk assessment of it. You decide, how did this happen? How do we make sure it never happens again? And are there any other things that we find out along the way that we want to risk mitigate before we say we're good to go again? That's why when you have things like the Challenger disaster and the Columbia disaster, NASA says, okay, everything goes on hold until we figure this out. And once we figure this out, what do we need to change or correct in order to make sure it doesn't happen again? And when Columbia went away, it was, okay, we've got some missions that are planned that have to be done. But after that, they scrubbed the entire space shuttle program. That's what they had to do. It was unsound from an astronaut safety perspective.
You're saying that you haven't heard that Russia took it seriously.
I don't think they took it seriously enough. No, the first time it happened, I don't know what their mindset was, but it's certainly not the same progress mindset as NASA would have. NASA would have said, okay, we're not launching any more Soyuz until we figure out what the source of the problem is. If it's software, we go in and we change the software, we run it through simulations again to make sure that there's no path through the software to make that happen ever again. And if you have to add a mechanical interlock, like a safety key or switch, to say, I don't care what the hell the software wants to do, we're docked right now, disarmed. So that's why, you know, there are still manual overrides in a lot of the systems on board spacecraft, because if the software goes wacky, you don't want certain things happening. So there are manual interlocks. Even
but they've got a history. Their history is full of bumping into things and stuff like that.
Yeah, well, you think it was bad when we mismeasured the adaptation of meters to inches. They actually had something similar where they went to land some cosmonauts coming back, and whoopsie, they landed a bit hard and they killed 3 cosmonauts.
Yeah.
Oh no.
This was years ago.
Yeah.
But, you know, the ground was coming up fast and they miscalculated the distance to the ground, and it landed just too fast. It didn't destroy the capsule, but it landed hard enough that it killed the cosmonauts.
All of them?
All 3 of them, yeah.
Yeah.
But that was decades ago. So
Still.
on happier note, Hubble has created a lot of data. The Hubble Space Telescope has created a lot of data over the years. And some of it is not strictly imaging. Some of it is spectroscopic data. And they were going back looking through some of the spectroscopic data for Jupiter's moon, Europa. And what they found was, you know, if you think years ago, Saturn's rings should have been gone by now, but they're not. And then we did some research, got some observations, and found out, oh, the rings are getting replenished on a regular basis. That's why they haven't disappeared. And they thought the same thing about Jupiter's moon, Europa. Not rings, but it's water vapor in its atmosphere. Europa is too small for its gravity to retain that much water vapor. The water vapor should have leaked off into space by now. And they found out that what's happening is the under ice ocean of Europa is actually leaking up through cracks in the surface of Europa and replenishing the water vapor in its atmosphere. But it's happening more on one side of the planet than on one side of the moon than the other. But the atmosphere is got enough gravity that the water vapor that's coming out is forming a sphere around the planet before leaking off into space. So that's how you get water vapor to hang around longer, is you've got an undersea ocean, and as you go whipping around Jupiter, you get that tidal effect, and it just makes the water make cracks through the ice and squirt out. And when it does that, you get more water vapor in your atmosphere.
Yeah, so the tidal effect is caused by the other moon. So whenever Europa is crossing in between Jupiter and another moon behind, or Io in front, it actually stretches out not just Io but also Europa, and then creates friction. So when you have a tidal friction, it actually makes, like, imagine like you're pushing a balloon, and the balloon becomes like instead to be a sphere, it becomes like a bumpy thing. So it becomes a geoid because of the tidal stresses. So that change when the orbit matches with other moons is that when it stretches and then causes this tidal effect in Io and Europa.
If you've ever kneaded dough, you will have realized that when you start kneading the dough is, you probably pulled it out of the refrigerator to let it rise a bit. And then when you start kneading it, the dough gets warm because you're compressing and stretching the dough. Same sort of thing on a very much larger scale with Jupiter's moon, Europa. The gravitational pull between all the moons going by it and Jupiter itself causes the moon to stretch. And when that happens, it causes it to heat up, and that heat keeps the liquid ocean beneath the ice under pressure, and that pressure causes cracks, and the cracks let the water vapor come out. They say that the ocean is salty or briny, And if you look at the cracks are all this brown color, and the top surface of the ice is whiter. So that would say that there's probably iron down in there. You get this rusty looking water coming up from the cracks and then freezing again. But if we were spending money on the right stuff, we would probably have something permanently in orbit of Europa doing observations close up, so we can watch things change over time. There's a couple of moons out there that we probably should have permanently orbiting craft, just like we do the Mars Reconnaissance Orbiter around Mars. But if we're that far out at Jupiter, then we'd probably need an RTG, and for that we need some plutonium.
But we need to be careful with Europa. It's not ours.
That's true. 2010, not 2001, 2010.
That was Io. Yeah.
No, it was Europa.
Now keep away from Io.
No, Europa.
No, Europa.
Really?
Yes,
Yeah,
it was
Europa.
Europa.
I'm wrong? Oh, gee.
Remember, attempt no landing there. I almost know the entire phrase. All of these worlds are yours. Use them as you will. Use them in peace.
Yeah, it was just on.
Europa, attempt no landing there.
Yeah, something like that.
Yeah, somewhat similar to that. But there was nothing about putting an orbital probe in orbit around Europa to do observations.
And get some spritz of the geysers and try to do,
I think that would be really cool to
get.
get a video recording of the geysers going off.
Yeah. No, I want to go like through one of the geysers and get samples.
No, you don't want to get that close. You don't want to get that close.
Biological,
Well, you could do
spreads
that,
out.
and they want to do that for Saturn, for Enceladus. They want to do that for Enceladus because Enceladus has enormous geysers that actually make it all the way to Saturn.
What movie are you talking about?
Attempt no
2010.
landing there. That came from the movie 2010.
2010. Okay. I didn't see it.
Roy
It was just-
Scheider, John
it's just
Lithgow.
on.
It was good stuff.
Someday I will
entertaining.
see it.
There were a few things that weren't right, but it was entertaining.
Well, that's good. Okay.
It
Something to
was
look
the
forward to.
continuous of 2001.
And in the
Space
cat
Odyssey.
and in the cat fight between the senior citizens. So William Shatner did do his suborbital arch on the Blue Origin spacecraft. He went up and came back down again. I think he was weightless for all of 10 minutes. and then
Wonderful.
came back down again, happy, healthy. But you think of actors as these stalwart characters, like he's the captain of a starship and he was an admiral and he's a manly man, and he was bawling like a baby when he got off out of the capsule. He was so
Well-
taken back by the event personally.
I thought it was wonderful.
I
Yeah,
loved it.
He
I loved
he was crying on Jeff Bezos' shoulder.
He didn't cry the whole time, just for a few
No, there
moments.
was a little bit. Yeah. he
No.
was emotional.
He was fine until he got out of the capsule and was standing on the platform, and he just wanted to thank Jeff. And it's like emotional outpouring happened. But I don't know what medication he's on, but he's 90 plus years old, and that's
Well,
something
yeah,
that can happen.
you get emotional when you get old. Yeah.
And you get
But-
emotional getting off of a trip that you took up into space that very few
Yes.
people have gone on.
Yes.
I can't imagine doing that, and doing it for 10 minutes is fantastic. And he
Okay.
did make all the flights of the stairs.
They showed no stills or video of Shatner mounting the stairs or making it to the top. I'm going to guess they hoisted him and you just don't have an image of it.
He was not puffy when he crossed the
No, he wasn't. He was standing on the platform, getting into the capsule like it was no problem. He's 90 years old and he's obese. That wouldn't be the case.
They stopped several times on the way up, right? There were 4 or 5 stories, so they would go up a story, stop. Jeff Bezos would, I guess, talk for a minute, and then they'd go up to the next level and so on. So they gave him a chance
Sit
to rest.
down. Yeah, gave him a chance to sit down.
Hey, I've been there at Yellowstone.
And me and Monroe puffing out, and my mom, who exercises, was
Hurry
like,
up, hurry
ready
up.
to go?
I'm
Hurry up.
fine. Let's go. Let's go. I don't even speak Portuguese, but I knew what she was saying.
Uh,
Yes, there's been this constant bickering between George Takei and Bill Shatner. Bill upstaged George 50 years ago during an episode of Star Trek, and George has never forgiven him.
Well, that's not nice.
Uh,
On Shatner, when he was talking, he at first he was just very calm, and then he got upset about a certain topic that came up for him in his thoughts about the Earth, about losing the Earth, right? Wasn't
Yes,
that?
yes.
no, about the Earth being so fragile.
Yeah.
Yeah.
And then he stopped being, you
Well,
know,
This is very common. Most
Yeah.
astronauts, when come back, they have that kind of feeling of noticing how thin is the atmosphere, how fragile is the cocoon that we live in, and all of them come back changed.
They only went up. They only went up about 65 miles. They didn't even go into orbit. It's just up and then back down again. Think about it this way: what is the driving distance from Fort Lauderdale to downtown Miami? It's almost 50 miles.
but
It's more than
well,
40.
the thing is going to
45
be,
miles, yeah.
okay,
Well-
we can take it as nonchalant and not that big of a deal until somebody dies on one of these trips. And then it's going to be a big deal.
Yes, but if it's an actor we know and love, it'll be a big deal. If it's a rich person that makes billions that we've never heard of before, it'll be like, well, lost a billionaire. What's the problem?
That was a stroke of genius.
I don't
'cause
know.
No.
He got so much free press for that.
They both did.
It was a stroke of genius. You know.
It was very
when
good.
they-
I
You know
agree
what's
with
going to
you,
happen.
Helen.
You know what's going to happen.
To have the first citizen go up, it was supposed to be a school teacher, but then they sent up a couple
Yeah.
senators instead,
Yeah.
and then they killed the school teacher.
Yeah. Well, actually, the citizen senator that they sent up was actually Bill Nelson from Florida, who's now the
He was
NASA
an
administrator. He's now the NASA administrator.
Right. And then
So-
they had John Glenn go up.
Yep.
When he was a citizen, he was no longer an astronaut.
Yeah, he was no longer a
Yeah.
senator at that point.
But in his case, it wasn't just to go. They were doing research on aging space and all bones and all. He was part of a
Yes.
medical research. They
Yes.
need
Yes.
to find someone who was, a certain age. But then you get retired astronauts. So let's get to the senator who's still, looking buff and healthy enough to go to space. Because the problem is that you get retired, you're a balloon, and then you don't have health to actually go to the space station. In his case, he's still trim, he still exercise, he was, in good shape. So that's why they chose him. It was more medical research.
So
Yes, it was,
in
yeah.
the bickering between Bill and George, who do you think the monkey wrench is going to be?
I don't know what George said of Bill. I missed that one.
George referred to Bill as a guinea pig.
Oh, really?
And,
Yeah, right?
he indicated he was a bit overweight too. So he's also a medical test for obesity.
That's horrible. I don't know. Can anybody hear me? I'm on a Bluetooth. Do you hear me?
Yeah,
Yes.
Yes, I hear you. And I agree with you. That is
Well,
horrible.
I saw the, a live, well, I saw it maybe a few minutes later, whatever. I'm going to tell you, I had two thoughts on this. One is, and I'm a relatively new Trekkie, of course I knew who William Shatner was for years. I've only become a so-called Trekkie in the last couple of years because there's a friend I'm with who is forever from day one, and Joe is too. But anyhow, I was moved by what to me was how profound. Okay, we know he's an actor, but he didn't have a script in front of him, and he
Right.
was really moved himself,
Yes.
and it was amazing. And one other quick thought now, just the other night discussing this with someone, I was thinking, you know what? I was thinking too bad that Leonard Nimoy was not still alive, because if Spock and Kirk went up together, that would have just
That would be awesome. That
Oh,
would be
yes,
awesome.
yes.
right?
Awesome
I
thought.
forgot about
Awesome.
George, you know.
Okay.
George rubs me the wrong way sometimes overall, but you know, I didn't know they had such a miserable feud going on.
Okay. If George wants to one up Bill, what he needs to do is talk to
SpaceX.
Elon Musk,
Yes.
go through his 6 weeks of training, and go orbital. So George can say, you just went up and down. I orbited.
Yeah, and George is trim enough to actually go. George is
Yeah.
keeping up with, you know, his body.
Yes. But I
Which,
still
by the
think
way,
I still think the most appropriate one to go up in a SpaceX capsule would be Tuvok from Voyager, because he's actually an amateur astronomer.
oh,
Does he have an interest of going up?
I don't know, but I don't know if anybody's asked him either. But he's actually done some educational promotional stuff with NASA.
you know, you mentioned training. Now, that's one thing I haven't heard discussed. I didn't follow this throughout. I was wondering myself, for this short flight, so to speak, what kind of training? Does anybody know how they prepare
Yes,
Shatner?
2 days. They have 2 days of training, and it's really
And
just
I know what kind of training is that.
it's really just
I have
safety
some kind
training.
of training like that.
Oh,
It's really just safety training. The Blue
Yes.
Origin capsule is fully automated. There is no pilot. One of the people on board is appointed the commander as sort of the most sane and rational one.
So in that case, I have a training like that for SoFIA, and it's basically I nicknamed the training is no touchy. Don't touch this.
Don't touch anything.
that.
And
don't
there's
touch
where your
that.
oxygen is.
So
Helen,
basically,
Helen, how
the
long was
training
your
that I have
training?
is no touchy.
Well,
No
how
touchy.
long was your training 2 days or longer?
It was it was actually for there. It was a week there, but I was a whole year training.
but
a
what
whole
about
year
the
training? A whole year training before you went up?
Not as an astronaut. She had to go through a lot of educational
I
postgraduate
had
work.
to take a physics outreach college grade astronomy for physics for teachers from Montana University, and then you have like instructions how to present things, how the mechanical part of the SoFIA works. So they are preparing us to answer questions about the airplane. So you need to learn the basics, so you could answer like hairy questions for 3 years old kids, or you know, people who why NASA is using $1 billion to build this, or you know, they prepare us to talk with the public, prepare us to talk with teachers, to do instructions, to understand the basics of the physics of infrared and a little bit of the airplane. And then when you get there, you have safety training, and the safety training is basic, like a very short flight attendant course. Where the emergency stuff is, where is the radio, where is the fire extinguishers, what kind of procedure you have to do for a few emergency cases. But basic is don't touch.
How long were you up for? How long were you up there?
I was in California for a week.
No, I mean up in the space.
20 hours.
20 hours.
It was
And when you
two flights of 10 hours.
And when you came back to Earth, were you interviewed?
Yeah, before and after.
Okay,
How
come
did
on,
your
you-
interview go? How did your interview?
Joanne, she was on
one
board
in
a
Spanish.
747, not a rocket.
I know, but it was still, she was higher up than 90%
Yeah,
of the people listening right
I
now.
had a few
Yeah,
interviews.
she was close to 50,000 feet.
So if you look at my name on you Google my name, put Helen Távora, you Google it, and then you put video, you can find the interview.
Yep.
I can find the interview, and you felt good about it?
Yeah. It's in
What about
Spanish.
what about the preparation for the sensation that I understand he did experience, all of them, of the weightlessness? It may not have lasted long, But I would think that's the biggie. You know, he talks about his stomach and, you know, I mean, how do you put, how, that's the
I
biggest
think
thing.
I think in that case is basic because they have safety procedures for everything. So I think they have some kind of timer, like this is time for you to remove your seat belts. This is time for you, you can float and you can do this, you can do that. Now it's time to go back. So basic is how to even, so like if it's the same seat belts that you use for the space shuttle, the ones that I use on SoFIA, you need to learn how to close that because it's not like very simple. It's like after you learn, it's simple, but it's complicated if you've never seen that closure before. And I'm mechanical inclined and I couldn't figure out until someone taught me how to do it. So a few things. So basic for me doing analogy, they basic were learning what not to touch. Don't open the door, don't open this. So it's like safety stuff. And then the other thing is that don't be away if some kind of emergency, but it's a very automatic. So that's not much to do.
But when the astronauts train, which is for much bigger and longer flights, obviously, so I always thought, I think I know that they train for, you know, not just the flying and floating around, but how their body is going to feel, like the stomach, for example. You know
Oh
what I
yeah,
mean?
they do the vomit comet
Because
flight.
we didn't know what could happen to our body before, so they were testing and see the limits of humans and see how much acceleration you could have. So that what we saw on TV for the Apollo missions is basic. We're learning how to do that. The training now, it's a little bit easier. What they do for the real astronauts is that in case you land on water, how you come out of your cabin, how you turn back, you like teaching you endurance, and if in case when you, and then those flights are orbital. So if something wrong happens, you could land anywhere on the planet, including the ocean. So you need to know how to survive in the ocean. You need to know how to survive in a forest, in a desert. So there are few contingencies for you to go in orbital. In that case, for those tourist flights, they don't even move much out of the States. It's like a very small area. So they do like a huge parabola that goes like this. So you don't even move out of the same county. So it's not need for too much training. When you go orbital, there are different things that you have to do. And nowadays, everything can be automatic. The astronauts don't like it, the things to be automatic, but most of the things you don't need to touch it.
But how did your stomach feel? Did you not get butterflies or nauseous?
No, nothing. I did so
but
great.
you didn't do any vomit comet ride.
Oh,
it was very nice. So the only difference that I noticed is that when I was speaking in my videos, I was speaking a little bit and doing like this, and then speak again. But I didn't notice while I was in the airplane. I just noticed later that I was doing that because I watched the videos.
At what distance does it become weightlessness? Right, you know. Like you went straight up 50 miles, I think, or 65, whatever.
No, that's just the edge of space. That's where the Earth's atmosphere thins out.
Right.
You won't get no. You won't get weightless until you're more than 100 miles up.
But they said that they did in this capsule a little bit. That's what I heard.
Yes, because they do an arc. They don't just go up and go into orbit. They actually do an arc. And at the top of it, it's just like the vomit comet. They just do a parabola. And when they do the parabola with the capsule lasts about 10 minutes. The parabola in an aircraft only lasts about 40 seconds. But they can do multiple of them.
I thought the way he even described it, that he went straight up and literally straight down. No, I'm wrong.
Yes. So
he goes straight up and straight down, but there's a curve at the top.
How come there's a curve? That's what I understand.
Oh yeah, sure.
No, if you go straight up, I think you
No.
drop straight down.
No, you don't go straight up and straight down.
That's what I
You go
thought.
up, and there's a slight curve at the top, and then you come down. And remember, the launch vehicle actually separates on your way up, and it comes back down independently of you, and then you move over slightly, and then you come down and you land by a parachute. So there's a little curve at the top, and it's only during that 10 minutes of curve that you get your weightlessness.
But that must seem like an eternity, that 10 minutes, I would think. I don't know.
Oh, no. Oh, no. If you're not having any physical discomfort by it, the 10 minutes goes by way too fast. You
So I
want it
guess
to last longer, and it won't.
I guess none of them really had any physical discomfort. Then I got the impression there might have been a little from him.
I would guess that they give you a physical, and then they control your diet for like 2 days before the flight to make sure that you're not eating the wrong kind of stuff too close to the flight.
Helen wanted to go back up, right? Helen wants to go back up.
Oh, I inscribed myself on the line for the Virgin Galactic.
Well, you signed up in Omaze. You couldn't afford an actual ticket on Virgin.
No, I don't even know if I won or not. I never looked.
So you really liked the feeling?
Oh, yes, for sure.
Well, she's never been in 0G.
But she still was in a spaceship.
Yes, but I was a regular
It was
gravity,
a 747. It was an aircraft. It was a 747. It's not a spaceship. It's not a spacecraft.
Well,
yeah,
it's considered that she is in a outer limit.
She didn't.
I was above the line where humans cannot survive.
Right.
They called it the cannon, or there was a C word. They called
the
it
air pressure's too low. The temperature's too low.
Cannon line? Is that what it's called? I heard something.
No, it's not. You're not above the Kármán line.
Not Kármán line. This is.
That's closer to 70 miles.
But
Armstrong line. It's
Armstrong line. Yes.
Didn't Shatner, the capsule, reach that line? That's what they were talking about.
Yes, that's the Armstrong line.
Oh, Armstrong. Okay.
There's different altitudes where you get certain classifications.
Yes.
And you know, I feel rather stupid, but who sits and thinks about this every day when there's a going up or a ship? We've seen this for many years, a good part of my life started. But the one thing I'll just say, he said what got him the most, and I'm like, I never realized that. So you get to the point where they got to that line or whatever.
Yeah.
And he said it was blue sky, and then instantly it was black.
Yes.
That freaked me out. That freaked me out. I never thought about that.
Okay. Remember how fast they were going. They were going faster than the speed of sound as they were reaching the top of their orbit, of their.
He said 2,000 miles an hour.
And when you're going that fast, the transition from 40 miles up to 50 miles up is a minute. So you're looking at a blue sky, and then in less than a minute, it goes pitch black.
But that's what I'm saying. I never thought about when the ships go up.
Yes.
They obviously all experience it, the regular ships, the shuttles, whatever. I never, they don't explain that. I've never heard anybody talk about it, any astronaut saying how that is. You don't think about it. You don't think, oh my God.
If you remember Helen's educational sessions about the thinness of the atmosphere on the Earth that we breathe, if you had a globe, like a 12-inch, like educational globe of the Earth, the part of the atmosphere that we breathe would be about the thickness of a sheet of paper.
That's what he was saying.
It would be the thickness of your hair.
Yeah. When you go above that level, the temperature's too low and the air pressure is too low for you to breathe, and then there's radiation in addition to that. So you need to be inside of a spacecraft. But that's less than 100 miles up. Think about it this way. If you're driving in a car, how far do you have to go to be 100 miles away from your house? Not far. Well, that's how high up you're going vertically. Just 100 miles.
But that instant transition is like, I couldn't.
It's not as instant as you think.
Oh,
but they're going faster than the speed of sound. They're probably doing about 1,200 miles an hour.
you know what he said?
It
He said
seems
2,000.
it seems instantaneous, but he was going very fast at the time.
But what about the ships that are normal, ships that take off?
Oh, they're going even faster because they're not suborbital. They're not just going in a loop. They're actually going into orbit.
So
I think he was
they-
also mentioning the difference between looking up and looking down.
Yes.
right,
When you're
right.
looking up,
Black.
it's pitch black.
Yeah.
And when you're
Right.
looking down, it's bright blue.
At the same time. Oh.
Yeah,
Yes.
so when you're in the face of the sun, where you the daytime that you can see the blue skies and the blue of the oceans, there's a lot of reflectivity that over exposes your eye. So when you look at the sky, you don't see. It's hard for you to see the stars. Maybe you can see the
Yes.
moon, and maybe you can see some bright planets. But because the Earth is so bright where you are, because they do that on daytime, you don't see stars. So it's
Now,
basically
if you're
blue
orbiting,
and black. Now,
If-
when
if-
you
if you're
orbit,
orbiting-
you go behind the Earth, and then you can see the pitch black of the Earth and the pitch black of the sky.
yes, if you're in orbit, like the SpaceX astronauts were,
Oh.
they were above the ISS. So they were really in orbit, and every 98 minutes,
We're above the ISS.
they were above the ISS. They went to find them an orbit that they could use for 3 days, and it turned
Okay.
out the orbit that was available to them was the part of the middle orbital altitude. They were just above low Earth. So they were above all the low Earth satellites, but well below the geostationary. So they were right at the edge, the upper edge
Leo.
of low Earth orbit. So that would put them above the ISS. They were higher than the ISS. They were higher than the Hubble Space Telescope.
Oh, wow.
Now, when you're up that high, you're not doing 90 minutes per orbit. You're doing about 98 minutes per orbit. So think about it this way. When you're going that fast around the Earth, every 98 minutes is a complete orbit. So every 46 minutes, 47 minutes, you get another daylight and another dark. And when it's dark, you're on the dark side of the Earth at that time because the Earth's rotating. So when you're on the dark side of the Earth and you look out into space, now you can see stars. But when you're on the daylight side of the Earth, there's this giant light pollution object called the Earth that makes it where you might be able to make out the moon, but you're not going to see any stars.
The whole thing is just unbelievable. I can't. You talk about that train. I've done train rides. I've mostly gone up and down to Florida by train over 40 years. Don't ask.
Yeah.
But 125 miles an hour, I don't think I could handle that. I just.
Have you ever flown in an airplane across country?
No, I'm lucky. I've been up
Okay.
and down the coast here.
I've flown transcontinental down to Australia, which was a 13-hour flight. That's a pain unto itself.
Yep.
And when you're flying in a trans-Pacific flight like that, you don't fly straight across. You go a great circle route. So you're at high altitude in the airplane for more than 12 hours. That's a long flight. And you can look out the window when you're down in the lower part of the Pacific Ocean, and the sky is just full of stars because there's no bright light anywhere around you. The brightest light is the airplane, and when the airplane's that far away from airports, they can turn off all but the minimal navigation lights. So you get to
At
see
night.
a lot of space.
But at night, right?
Yes.
But the feeling of 125 miles, I know people do it in cars racing, but
Oh, that
And
no,
you
that was back when transcontinental, trans-Pacific flights, they could do 550 miles an hour. Nowadays, they're barely doing 400.
but you said that you want to take that train next year, to Orlando.
Yes.
That's the one and
Yes,
that's
it'll be
fast.
going 125 miles an hour between the city of Cocoa and Orlando.
That's gonna feel awfully fast. I mean, even on
Oh, no.
You don't
When I was
feel
in
it,
China,
though,
it was
do you?
going. When I was in China, it was going more than 100 miles an hour faster than that.
But did you sense that the speed was that fast when you were going? Like you
Oh
said,
no, when
you looked
you're
at
on
the
board
film.
when you're on board the train, if it's a modern high-speed train, there's no clickety clickety of the tracks. The tracks are all welded together, and they're all spec rail. So there's not a lot of bumping, and the cars are on air ride suspension, so you don't hear any wind noise. You don't get any vibration. There's no rattling of the train. It's just.
What's spec rail?
And when you look out the window, you saw it as normal.
It
The
looks
camera
normal.
then,
When you look out the
Yeah.
windows, it looks normal because your brain compensates.
right?
Really?
Yes.
Yeah.
Yes.
And so the camera took the real picture of what was happening, but your brain didn't see that.
No, your
So
brain
you
doesn't.
don't. So
Your
you
brain
don't
doesn't see it. Your
sense-
brain compensates. And
You don't sense the speed you're going. Sort of like
No.
when you're in a car sometimes, and if you have all the suspension and you have the high class stuff, so you don't feel certain motion in a car. I mean, I can change between my mom's car and my car. My car, I can always sense what speed I'm going. But in her car, it's a Cadillac that has all these fancy things on them that they're up to date. You don't sense the speed the same
Correct.
way.
Correct. You're isolated from the external environment.
Yeah.
And
My-
to answer Joe, spec rail is they have a computerized piece of equipment guiding the rails as they're being laid down, and the rail height between the rails and the separation is like millimeter level perfection. And when they weld the rails together, they actually use thermite, magnesium aluminum melting, and that actually seals the rails together. And then they use a grinder to grind down the seams. So there's no clackety clack between those rails.
I can't picture how the scenery looks the same. I made so many train trips, and that's one of the pleasures of going on the train is watching. It's not interesting all the time, but you watch people. I always felt like I'm watching people's lives as I'm, driving by.
Okay,
And-
okay. Here's the difference. On older trains that could do maybe 100 miles an hour, you didn't have continuous windows. You had there was a couple of window panes, and then there was a section of bulkhead. There was like metal you couldn't see through, and then there was some more windows, and then there was some more metal. So there was window, metal, window, metal. So if you were looking out one window, you could see the scenery passing, and you would see the gaps. So it would make it look like things are going fast. But on these modern high-speed trains, it's joined together glass, and it's continuous glass down the length of the car. So you've got this huge panorama, and you can see well off into the distance on the horizon. And when you're looking that far onto the horizon and you're moving fast, you don't notice the speed.
Well, I didn't mean to say that I felt I was going fast. I felt I was like watching a movie, of people's lives, even if it was just a parking lot. I didn't feel it. I mean, this Florida to New York, basically, and vice versa. I don't know how fast they were going. Now it's been 36 years since I've been on a train, a plane.
Well, the other thing is when you're moving that fast on a train, anything that's moving much slower than you on the ground looks stationary. So if the train is going by traffic that's doing 50 miles an hour, the cars look like they're sitting still.
Oh, that I can kind of realize now.
Yeah.
I see what you're saying. That's interesting.
It's just that relative speed thing that Einstein talked about.
I think that would be beautiful to have that welded window all the way down the side.
Yes. Well, that's why I want to ride the Bright Line, because these are the most contemporary Siemens manufactured train cars in the world. Now,
And have they had any accidents reported on these trains?
No, train accidents usually happen on the old trains, the ones that are not well maintained, or the tracks aren't well maintained, or there's
there are problems sometimes, whatever the problem. I mean,
or the train conductor was on drugs or alcohol, or
somebody winds up on the rail for some reason.
Some truck or car is sitting on the rails like an idiot.
Right, exactly. Or they conked out for some reason. But whatever reason, There,
Yeah.
there are train problems, but I haven't ever heard of the bullet. And the bullet's been out there, what, 20? You're saying
Yes,
maybe?
the Japanese were the first to come out with the bullet trains, and they were doing about 180 miles an hour initially. They're all now, well above 200. The newest ones in China are closer to 300. But when you get to 300, the rail friction starts to be your enemy, and you put more energy into it, and you just can't go any faster. It's not the aerodynamics, it's the rail friction. So the maglev trains get to be about 330 miles an hour. So the Chinese maglev train, and I think it's faster than the German maglev. The German maglev used to hold the world title, and now I think it's the Chinese maglev train. These are trains that have superconducting magnets, and they never touch the actual rail. And it's not a wheel on rail, it's actually an encompassing rail. It's kind of like a monorail. But they're always hovering above the rail, and they use liquid hydrogen to keep the superconductors cold. Not liquid hydrogen, liquid helium to keep these superconductors cold.
Didn't they have a plan to have that bullet train in for no good reason, in my opinion, in California? Isn't that where we heard that expression in this country, the bullet train?
I've recently started looking into why the U.S. does not have high-speed rail, be it private or federal. And it turns out federal is a problem because the lobbyists for the transportation industry and the oil companies don't want it to displace them. And the reason why nobody privately does it is because local governments will find all kinds of red tape to either slow down the process or make it egregiously expensive. I was looking, because once Brightline has its rail system that goes to the Orlando airport, they want to extend it to go over to Tampa. And what they wanted to do was, on their way from the Orlando airport to Tampa, they wanted to have a station at one of the Disney theme parks. I think it's the Wild West one. I think it's Disney West or something like that. And Disney was fine with that because Brightline was paying all the bill. They paid the bill for the right-of-way. They're going to pay the bill for the track, for the train, to operate it, everything. Disney's just providing a spot on the ground where they can have a station. But all the other entertainment sites in the Orlando area were really pissed off at Disney for doing that. So they talked to the local Orlando city and Orange County government and said, no, you've got to make this zigzag path near all the big name sites if you want to make it to Tampa. And the price for Brightline's rail extension from Orlando to Tampa went from $1.5 billion to almost $3 billion, because they have to buy right away and lay down additional track for all that curvy track. It's not a straight line anymore. So that's why we don't have high-speed rail in the U.S. There's too many lobbyists against it.
But I can't blame those businesses, because they're going to be like, if people take the train, and I didn't realize the airport was involved, let's say to Disney World, and then they don't want to go rent a car just to go to these other sites. I kind of understand what they're saying in that regard. Years
ago, Disney was going to put in an extension of their monorail system from Epcot Center's monorail station all the way to the Orlando airport. But they would have to go past Universal Studios, their competitor. And Universal said, you're going to have to pay us for the right of the way, and we want you, Disney, to pay for the Universal station. And Disney said, I don't think so. But the Orange County government said, no, we're not going to fund that. But the Orange County government has this lovely convention center that I've been to many times. Why doesn't the Orange County and Orlando government get together and put in a train extension of their own, a light rail system to go from the convention center to the airport?
Okay, that makes sense.
No, that doesn't make sense. That doesn't make sense, because you'll kill the rental car agencies and the taxi services.
Well,
I just, Monroe,
Yes.
6.5 billion, right? Interesting.
You said you traveled in China and Japan, and maybe you on the bullet, and maybe you know the answer to this is.
I did not go to Japan. I just know about their bullet train.
Oh, okay. But okay, maybe you know the answer to this though, because you're bringing it up for the United States. How did these bullets trains affect these other countries?
They didn't care. They said, this is progress, folks. This is where things need to go. And the governments got behind them and said, okay, we're going to allocate basically government dollars to make these things happen. In the case of Japan, there was some private enterprise for it, but the trains stopped off in all the major industrial cities. So they provided a means whereby you could get employees from other parts of Japan into the major industrial cities to work in the factories, because Japan has a land use problem. It's not that big an island.
Exactly.
So
And
if
and
they
you
could
have
take
to-
some rural area and have homes built there, and then you could daily commute on the bullet train to the auto manufacturing plant as your job, that worked out for the big corporations.
And it's other thing too is that when those countries they have their Bundesstaat or their federations, the central government has a little bit more power. So if the central government decides that's going to go and they're going to do the project, so normally those tracks are federal, so the federal government level. So it's like it makes easier because it's just one area that's deciding everything, is buying everything, is doing everything for the laying of the whole line in the country. So it creates uniformity. There is no problem with one having some kind of compatibility with the other states or changing prices, or so it facilitates because there is investment of the governments to actually do that, and none of them are making profit because this is a service to the public. It's not to make profit.
Well, let me give you a balance here. Your gasoline dollars are the money by which Dubai builds massive hotels and islands for the wealthy. Your Walmart and Target dollars are what allows China to build high-speed rail systems, to have a space program, to have quantum computers. It's a different approach to where do you spend this mad money that you suddenly have billions.
And your Amazon expenses go to Jeff Bezos to have fun.
Listen, just recently, in the last number of months, whatever, I could not believe. I was looking up China for something, led me to want to look up a certain city. I almost lost my mind. I said, this can't be real. This has to be a movie set. Has anybody here ever seen? I mean, you've been there in person. What is going on there? The buildings, things you cannot even imagine that we do not have in this country here. I couldn't believe it. I absolutely couldn't believe it that they are able to do this.
You're looking at the futuristic buildings of Shanghai. Yeah,
probably.
Yes.
They're beautiful, but nobody lives in them.
Well,
no. You're thinking of the massive condominium build-outs for the population as they were expected to move from agricultural to big cities, and they overbuilt them. And that was actually the Chinese financial money pockets guys trying to copy the practices that led to the financial downfall of the U.S. When we had our economic collapse, it was because of junk bond funding. Well, in the case of China, they so overly built out condominiums expecting people to move into them, and they just kept raising the real estate prices until people couldn't afford it. So when you build one on top of the other, eventually the financial props fall away. Corporation in China that has been building all these just enormous complexes of condominiums. But the real estate companies are so milking the market that nobody can afford them anymore. And when the revenue coming in drops below a certain level, you can no longer afford to pay for the buildings you've already built.
But Monroe, I saw, it wasn't a 2020. What is the name of that program? Where they went in and they showed that they didn't just build the condominiums, which they did build a lot of them, but they also built the malls, the empty malls. They built a lot of different things.
If you build a condominium area for 100,000 people and only 10,000 people actually show up to move in there, that's only 10% occupancy, which sounds horrible, but that's 10,000 people that are living there. But you have to, if your goal is to have 100,000 people, you better have all kinds of businesses and shopping malls and groceries and hospitals, and you're building a city. But if you only have 10,000 people there, you've built out all this infrastructure that's going to be very much underutilized. It's going to be 90% underutilized.
It is underutilized. They
Yeah.
showed these beautiful buildings underutilized. Now,
Yeah.
of course, I saw this program probably 7 years ago. So I don't know how China has worked it out, but it seems
It's going to collapse. The private investment money is going to collapse, and then the Chinese government's just going to take it over, and they're going to offer those same properties at a much more reasonable price point to the average Chinese citizen, but they're going to be government housing.
Well, that would be wonderful in a sense, because where the Chinese people live now is horrible. Horrible.
Well, it depends upon where you are.
Well, most, I mean, okay.
No,
just
not
take
most.
China.
That was decades
average.
ago.
Okay, so you're saying that Hong Kong area, that was all the people that were living on the waterfront because there wasn't enough places
They still are.
in the country.
They still are, because the local cities have no ability to build out anything, because they would have to displace those people in order to build, because they have no space left.
Exactly.
Yeah.
And there were places in Beijing and in the Shanghai and other
Well, the
places.
same thing's happening in India. In India, there are cities that are so built out, they have, tens of millions of people living in space that is way too small for that. And there's no place for them to build, even if the government wanted to build.
Right.
So they're kind of stuck, but they don't mind, escorting people out to build wealthy people condominiums. That's okay.
But China has all these places. I mean, they have a lot of places where these people could go to and live in these cities if they could afford them.
But they're owned by private Chinese corporations, and they have real estate trusts that just kept jacking up the price for whatever the market will, provide them in U.S. real estate fashion. And that's going to be their downfall, is the same toxic price increases that killed our market are going to kill their market 10x times what happened to us.
Yeah.
But in the case of China, in the case of China, the central government's just going to let those private corporations collapse, and then they're going to take over the properties, and then they're going to offer them at a much more reasonable price.
And then they're going to be able to say, see, capitalism doesn't work.
Well, does it?
I think it works.
Okay, if it works, how come we had a financial collapse? Because of greed.
Nothing's perfect. Nothing's perfect.
People make
There you go.
I mean, that's not all the time, I hear.
No, it goes in curves. It goes, look, we're making a lot of money. Let's raise the price on everything. And then you no longer have the money left to take anything forward. Anyway, enough about Shatner and decay.
Thank you. I like Shatner.
Okay.
I like talking about it.
So I don't know how many people have been following the semiconductor chip shortage, computer chip shortage, but I used to work in the electronics industry, and I understand what's going on now. The major auto manufacturers outsourced all of their electronic circuit boards and what processors were used on them, and they have not renewed them, put new processors in, new generations of processors in over 10 years. And when the pandemic happened, GM, Ford, Chrysler, Volkswagen, all those companies could have said, continue to send us the chips, because once this thing is over, we're going to need to build cars quickly when things recover. And they didn't. The major car manufacturers said, stop sending us chips. We don't want to pay for them. We don't want inventory to build up while we're not selling cars, despite the chips being a very small portion of the total price of the car. But they were being cheap that way. But in the interim, all the companies that were making the chips said, I'm sorry, guys, we still got to make a living. And if you think about it for a moment, if you said, how many cars are made in the world every year? And it's probably close to 20 million cars. How many mobile phones are made every year? Hundreds of millions of them. Where do you think the chip companies are going to find their new source of revenue? They're going to make the more contemporary chips for the latest mobile phones and tablets and computers, and they're going to let those 10-year-old chips that the auto manufacturers want to stay on dry up and blow away. And that's exactly what happened. In the case of Tesla, since they spec their own chips, their chips were still being made because they still kept the order flow going. So Tesla did not have the same problem with chip shortages as did GM, Ford, Chrysler, and all of the different brands under Volkswagen. Basically these recognizable car names are running with computer chips that are 10 years old, and the chip manufacturers no longer want to make those antiques. So now that they're trying to turn back on their production lines, they showed a parking lot where GM wants to sell pickup trucks because they make a bigger margin off of them, but the sedans that weren't selling, that already had the computer boards in them, they were taking the boards out of the fully built cars and putting them in pickup trucks and letting the sedans just sit in the parking lot as inoperable. That's how they solved their problem. So they're creating this problem that's just rolling down the road of, you've got to go back to your third-party companies and have them build new circuit boards with the latest processors, and that's going to cost probably tens of millions of dollars to each of the major car companies before they're going to get back to the point where they can do volume production. So I understand this. When I was working for the company that I worked for, that I helped to found, every 3 years, we literally had to go out and use the next generation of chips and the next faster, higher density hard disk drives, because the companies weren't making the old stuff anymore. And if you wanted to keep using the old stuff for another year or two, you had to do what is known as a last time buy. So you would buy up their no longer going to be produced inventory. And once you did that, there were no more. So the day you make your last time buy, you better get on that new design pronto. So in the case of the big car companies, they not only didn't buy out the current inventory, they didn't do a last time buy. So the chips that they're using do not exist anymore, except in the circuit boards they've already put them in, and they built them into cars, and they're taking them out of the cars and putting it in pickup trucks. So,
Apple did that too, so they could repair their computers.
yes.
But the other computer manufacturers squawked like crazy because Apple bought up all the chips.
Yeah. Well, that's where Dell, who sells mostly Intel products, still had processors, and Apple, who wants to use their new RISC-based AMD processors, they were grabbing all the chips that they could get and putting all of the other people out of chips. But over in China, since the ARM processors are an open source technology, other companies can make the ARM processor chips, not just AMD.
Mm-hmm.
So, it's wherever you can get them and make them. It's kind of like batteries in electric vehicles. Where do you get your batteries from? Well, people don't know this, but Tesla does not make their own batteries. they have contracts with companies that make the batteries. But Tesla has contracts with probably half a dozen different battery manufacturers, and they roll them forward to make newer and better technology batteries all the time. So when GM sort of locks and loads on a particular battery chemistry and design, and that turns out to be not the cheapest and not the best, they're stuck with that because they've outsourced everything. They don't have their own design specs. So they just go to like LG Chemical, you know, and when their cars are catching fire, they're stuck with that battery system for a while until they can get the new design in. So they just stop selling them. So that's why we have a chip shortage. It's not because of COVID itself. It's not because of the pandemic. It's not because people don't want to work. It's because Ford, GM, Toyota, Volkswagen, the parent company of Chrysler and Dodge, they literally said, we're not going to buy chips that we can't immediately put in cars. And the chip makers just passed them by and said, fine, we're not making those chips anymore. When you figure it out, let us know.
Mm-hmm.
So, and in a similar vein, I found out what's happening at the Port of Los Angeles and the Port of San Diego. As new things come up and say, well, this is why we can't get them, the container ships processed as quickly as we used to. Well, they're running below capacity and saying it's COVID. Not at the Port of Los Angeles because you don't have any constraints anymore there. It's the union workers, and the union, the port authority, the port workers union said, sorry, what do they call it? The ship workers union. They came in and said, all our people are out there that can be out there, so we're not the ones holding it up. And then they went back to the Port of Los Angeles and said, it's the management of the Port of Los Angeles. And the Port of Los Angeles says, no, it's not us. It's the truck drivers. And the Teamsters Union came in and said, we're giving you every truck driver that you want. And what it turned out to be was the Port Authority was not wanting to pay overtime. So they were cutting back, kind of like the Postal Service. When the Postal Service says we're not going to pay overtime, you can't get as much done. Now, why would the Port of Los Angeles and the Port of San Diego be having so much difficulty getting all the freight processed when New York, when the East Coast ports aren't having a problem? Miami doesn't have this problem. Fort Lauderdale doesn't have the problem. Jacksonville doesn't have the problem. Like, is it just the West Coast? No, it just happens to be these two ports. Have you heard of anything happening similar to this fashion in Portland? Because they have a big seaport up there too. Just happens to be these two major hubs. I was listening to one of the companies that manages the actual containers and saying, well, it's because we've lost a couple of thousand containers in the last few years. Okay, each one of these ships alone is over 1,000 containers. These are Panamax-sized ships. They can go through the Panama Canal at its new size, carrying even more containers, and they're stacked, more than 10 containers high above deck and more below deck. So you could lose 1,000 containers, and that's just one out of the 50 plus ships that's waiting to get into the Port of Los Angeles. So it's not for lack of containers. Okay, and I posted our EM drive and photonic propulsion presentation on YouTube, and I put it out there in two forms because we yammered on for more than 3 hours. I said, nobody that wants to look at this topic outside that's general public is not going to want to watch something for 3+ hours. So I said, let me cut out all the stuff that's not specific to the topic, all the sidebar comments and stuff, and just say, let's just focus on the presentation and any comments directly on the presentation. And it was 2 hours and 2 minutes or something. I said, well, I got rid of 1 hour. So there's a short version for 2 hours, and there's the long version, which is over 3 hours. City of Fort Lauderdale spends your tax dollars, bed tax dollars, and they have tourism events. And they have weekly tourism events that include a couple of the different beachfront parks on Fort Lauderdale Beach. And there's 3 of these parks, and it's called The Loop. And one of these parks is the Las Olas Beach Park. And it's a lovely open terrace. It's got a artificial turf area where you can sit or lay on the grass and chill out. And they have a little musical bandstand there. So every Saturday during certain months of the year, cooler months of the year, they'll have a band there. And the city pays a promotional company to pay the bands to be there. And Helen suggested it, and after a couple hours delay, she and I went there yesterday evening and evaluated and said, hey, this would be a good place to do some public astronomy outreach. But since I'm not a nonprofit, as the saying goes, you couldn't pay me to do this. So I'm going to look at the background information on this event. It's called the Friday Night Sound Waves musical event on Fort Lauderdale Beach. And they have budget money annually to a promotional company, and the promotional company has budget money for different things that take place during each one of the events, and they have a total, and then they divide it up across the events. So getting them to pry some of their annual budget money loose to give us a sizable chunk isn't going to happen. It'll be maybe, I'd say, around $150 to $250 tops per event. But I'll dig further into it, and Helen and I will do some brainstorming and see where it goes. But that could get us back into the public observing business again and promote what we're doing.
How much are you going to ask to be paid for the event?
Well, I found out that the dancers that were there, that we saw there last night, they were getting $120 a piece for each event. And all they did was come in sort of dancer, ballerina kind of costumes with these long flowing wings. They look like wings attached to their arms, and they had white lights on them underneath, rows of strings of white lights. So when they fanned out, they kind of looked like an illuminated butterflies. And they were getting about
The kids loved it.
And they were getting about $120 a piece. I found out that the band, excluding whatever the band themselves pay for their own promotion, was getting $1,900. The band gets free parking. The butterflies.
What about the DJ?
The butterflies have to pay for their own parking.
What about the DJ?
He was part of the band.
Oh, okay.
Yeah. So it's a package. Like I said, it's a package deal. It's fun to look at this because you see package promotion on top of package promotion on top of package promotion. So when you finally get down to the actual artist, they're getting chump change, but they're happy for the exposure. So that's something we'll be looking into. And next week's presentation, we're going to do some thought experiment. When we looked at the EM drive and photonic propulsion, it was kind of taking physics, tweaking it, and saying, what else can we do with it? Maybe in the future. It's kind of like, fusion, dark energy, dark matter. They don't have a good handle on any of those yet, but they're spending a lot of money to see where it goes. And I thought, well, there's got to be an endpoint to that. What is the most advanced technology anyone can think of, even in science fiction, that would be like, once you have this, what more do you need? And interdimensional transportation is the one I came up with. So next week we'll be discussing that. And no, it's not technology that you can currently go buy into, but I think that ought to be a fun thought experiment. And if anybody's got any other things for future sessions, just shoot me an email. But tonight we're going to talk about the pan-tilt zoom surveillance camera. I've got a little more detail on it. Unfortunately, the sky's gone to crap here, so I'm not going to fire up the camera again.
I thought your camera was going to stay outside. I didn't realize you were going to have to take it in and out every meeting.
Okay, you must have missed some of the dots along the way. I'm not going to put it outside until I resolve the issues I'm currently having with it, because I don't want to have to keep climbing up on the roof and working with it. So
Yeah.
once I get those issues out of the way, I already have the plumbing, so to speak, to mount it on the roof.
The problem is the old voiding the warranty kind of thing,
Oh, I've already done that.
because he's using out of the specs. So that camera is surveillance camera, not astronomical camera.
I'm using it for not its intended purpose, but then I do that all the time.
And you keep all of this on an account type thing, so you know how much you're spending
Oh yeah.
for.
Oh yeah, because I want things to be reproducible. So I have Excel spreadsheets that have a line by line list of here's what I need to buy for this purpose, and here's the manufacturer and the manufacturer's part number, and here's who I bought it from, and the seller's part number and the link to the seller's web page. Here's what I paid for it, and then I roll all that up. So,
And
yeah,
I pretend to read and agree with everything.
Yeah. So, okay. So welcome. Tonight we're going to discuss using off-the-shelf pan-tilt zoom surveillance cameras for amateur astronomy observing. The idea is to see if we can't take one of these and repurpose it for astronomical observing. And that way you could leave it set up always outside under a protective dome that's not a normal telescope observatory dome, which is less expensive. So it would always be there where you could use it, making it easy. And easy is the great way to have satisfaction in your observing. So here's the particular camera that I've been playing with. It's an under $250 camera. It's a 8 megapixel camera. So it's very high resolution, and it's very high fidelity. It does a 12-bit analog to digital converter. It has a focal ratio anywhere from f1.6 to f2.8. It's almost an 85 millimeter aperture. So it may sound small compared to a 16-inch telescope, but it's got an 8 megapixel digital imager behind it. So it does have high resolution images, and it does wide dynamic range, so it can tell light versus dark by more than a few gray levels. It is not Peltier cool. It does have a weatherproof enclosure. And unlike a USB camera, which streams very fast but drops frames on the floor, this is an Ethernet connected camera, so it will never stream faster than your Ethernet interface can take it. And you can use a single cable on which you can run both the power and the data, so it's easy to hook up. And it uses an open standard called ONVIF to interface with the camera. So as newer models come into being with more capabilities, once you're interfacing to it, you don't have to keep reinventing the wheel. This is what the camera looks like. You could fit the top of the camera into my open fist like that, and it's about this high. And normally it would be hanging down, so it could see downward to 90 degrees, but you couldn't see above the horizon. So what I do is I invert it, so now you can see up to the zenith and then down to the horizon, but you can't see below the horizon. So once it's in this mode, it's no longer usable as a surveillance camera. And it has a lot of electronics on the inside of it, a lot more than your average astronomy camera. So you got to ask, if this is $250, then you see 3 motors and all these circuit boards. Why am I paying $700 for a cheap astronomy camera? It's because
Because you know
they
they're
might sell
coming.
millions of these, whereas your astronomy camera in a good year, they might sell a few hundred. So this can be cheaper per unit. And if you can ride on that piggyback, it'll be better. So what else do you need? Well, you need a glass dome to protect it because you've inverted it. And now that it's inverted, rain can get in. So you put a glass dome over it. You need to turn off the infrared LEDs that they would normally use for illumination because you won't need those for celestial targets. And you can see up to 90 degrees and you can see down to the horizon, and then you can see 360 degrees around. You need a power injector. Those are going to run, if you just do a single port, it's only $11. If you want to do a little LAN switch, that's under $40. To give it the power over the single cable, but it's easier to wire up. Because I doubt you have a wall outlet on your roof, and you don't want to run this thing on batteries because you'd have to change them all the time. So what can you see with it? Well, you can do a time lapse to do meteor showers. You can see the moon, planets, large, bright, deep sky objects like the Orion Nebula and the Pleiades. In the daytime, if you zoom it out and you look at the same field of view and at the same sidereal time every day, you snap an image, you can actually see that the sun moves in a lazy figure eight called an analemma. Or if you're just curious, you can watch aircraft, helicopters, drones, and satellites going over your house. So what else is needed is the software drivers. And there's two drivers. There's one driver for making the camera operate like a telescope mount. And there's another driver for making the camera operate like an astronomical camera. And once those drivers are done, then you can use off-the-shelf software like Stellarium or K-Stars or Cart to Seal to look at the sky from a simulation perspective. See, oh look, there's Jupiter. I want to go see Jupiter. And then you can have it command the camera to go over and show you Jupiter, and then you can zoom in on it and snap pictures or do videos. So this open standard for interfacing to it is called ONBIF, and here's information on the specs of it. There's different profiles for the pan tilt zoom commanding. Then for the imaging, you can do JPEG snapshots. It's a very nice open standard. It also means that once we have a driver that can talk these profiles, if a new camera that has more capability or a lower price point comes out, it's easy to adopt it. So here's the wiring connects. These are the actual cabling between things. So on the right, you see the camera, and then you see it needs data and a power connection. And then you have a power injector that will take the 48 volts DC and send that over the same wire as the data to the camera. So you can have a 300-foot long cable between the power injector and the camera, because remember, you're going to put it up on your roof. You connect that into your home network. So you'll have your laptop, your desktop, whatever your application computer is running your planetarium software and your imaging software. And then that would talk to one of those little Raspberry Pi computers. That would be where the drivers that talk to the camera are running. And then if you want to hook that up to your internet router, you can grab images and send them out to the internet and save them in the cloud or whatever you want to do.
Excuse me, Minref. Pi
Yes.
computer. Can you talk about that Pi thing again? I forgot what that. I know you talked about it in one of the other presentations, but I can't remember.
And here it is. Okay.
Oh.
That's a good segue. Nowadays, they make computers that are very small.
It is incredible. They are coming very small and the price is very low. Remember, like 10 years ago, when we were trying to develop computers that would be about $100 to send to countries so the kids could learn.
This is the
look at the
computer.
size.
This is the computer. Let's see.
This would be like the big tower that you used to have in your house, right?
Yeah.
Can you turn on the side? Just to see how
I can
thin
do
it
better than
is.
that. There you
There
go.
you go. Yeah.
Now,
So
can you
that's
turn
the
on the side?
computer.
What Joe
That's
has
how
one
thick
too?
it is.
That's the computer. This is the USB cable that connects to a network interface to give me, you know, my RJ45 Cat5 cable connection to my home network.
So
And
cable of the internet.
yeah, and it's not cable internet though, it's just an internet cable. And there's another interface right here that's like this one, it's another small connector, and that's where the power plug goes.
Are you using it for what you're talking about tonight, or?
Yes, this is the computer I'm actually developing the drivers on. This runs the Linux operating system. It's a version of Linux called Debian. That's a packaging of the Linux operating system. And it runs server software.
Did Joe show one too? Did Joe show one too?
I
Does
don't
Joe
know.
have one? Joe?
Oh, no, negative.
Oh, I
Yeah.
thought you showed it. I saw.
No, I
okay.
said good because he lit it up.
Yeah.
Oh, okay.
I turned on my ring light to give it a little spotlight effect there.
There you go. Yeah, we see it
Oh
now.
yeah, that's good.
Now,
This
What
is
it-
a whole computer.
what is the disk storage? Let me show you the disk storage. I got to get access to it here now. There we go. That's the disk
And
storage.
And this probably has more memory, like 100 times more memory than my first computer.
This is a 32 gigabyte solid state memory chip.
My first computer was 5 megabytes.
Yeah. And
Pentium 5.
that just slides in there. That contains the operating system, all of the application software, the data from the camera. Now, how would you hook this up to a display? There's an HDMI port right there. So I can actually hook this up to my TV set if I wanted to. And since it has a USB, instead of hooking up this adapter, which just has Ethernet on it, I can hook up a little USB hub that also has Ethernet on it. So I can have 3 ports of USB and Ethernet all in one box. It's a little longer than this one, but it looks pretty similar.
So you can hook up a keyboard, a mouse.
Keyboard, a mouse, all that stuff works with it. But I've been using, that's a Raspberry Pi Zero W. The W stands for wireless. Oh, by the way, the computer also includes Wi-Fi and Bluetooth.
Incredible.
Oh, it's 1 gigabyte of RAM, and the processor runs at 1 gigahertz. Oh, the bare board of the processor itself is $10. Quantity 1.
Oh, wow.
The case that you buy for it, the case by itself is $9. So the case is 9/10 of the price of the computer board. And it's just 2 pieces of plastic.
That's incredible.
Yeah.
So what he's talking about there is the big box that we used to have as computer. That's it.
Yes. Now, the computer board itself is not enough to make it usable. You still need that solid state memory chip. You still need the case for it. You'd like to put a heat sink on it so that it keeps it cool. You don't need a fan. It's not producing enough heat that you need a fan. You need a power supply for it. And you need that USB hub to Ethernet adapter. And then if you want to hook that up to a TV, you need like, a small HDMI connector to a normal full-size HDMI connector. And you can buy all of that as a kit for $45. That allows you can hook up a USB keyboard, USB mouse, hook it up to your TV set. But it runs the Raspberry Pi OS, which is Debian Linux. And then on top of that, you add the instrument neutral device interface, INDI server software. That's available. You just download it and install it. And then you write drivers, and you write a driver for the telescope mount, and you write a driver for the camera interface, and those talk to the surveillance camera using that ONDIF interface. So that's the part that I have yet to write, which is why earlier this evening we were talking to the camera using a web browser interface, but Microsoft Edge, when they came out with their browser to replace Internet Explorer, it doesn't have all the same capabilities. So they, in a crippled manner, will let you cobble together Internet Explorer running within Edge, and it just runs slow as a dog, which is why I was having so much difficulty with it earlier. But once I talk directly to the camera using these drivers, that's performance is not going to be as an issue. And if you want to say how the software hooks together, that's what this diagram shows. So on the left, you have your application computer. That's the thing that's going to be running your planetarium software, your stellarium, and your image capture software. That'll all run in there. That'll talk to the Indy client software, which will talk to a network connection. You make a network connection to the camera and to that little Raspberry Pi computer. You run the Indy server software on the Raspberry Pi, and then you run the two drivers, one for the telescope mount and one for the camera. So this is what the camera looks like inside of its glass dome. I use a polyurethane foam packing to fill the gap between the glass dome, which is slightly larger than the camera mount, on the bottom of the camera mount. And I need to put a seal at the bottom of it to make it where the glass dome, as the urethane foam expands and contracts with heat from the sun, because when it gets hot, it expands out and makes a nice seal. But then if you wait until later in the evening when it gets cooler, the air molecules inside the polyurethane foam get smaller. They get closer together. And when they do, the dome tends to like slip down. So I have to put a bead around the bottom of it to keep the dome from slipping down, which is why I have that red text at the bottom. Dome slides under downward pressure. We'll need to add stop/seal at bottom. Making notes for myself. And had to use a glass dome. It's fairly thick. It's a display dome. It's fairly thick. You can obviously see through it. If I were to use polystyrene or acrylic, it would be damaged by sun ultraviolet exposure. It would either craze over or crack. So glass was the right way to go. So this is my test stand. While I'm debugging the software and testing it out, and this is what actually I ran earlier this evening. I have it sitting in my living room. It's the camera on a pipe, and then that's mounted on a piece of plywood. And then I have the power and data cable coming up through the center of the pipe. So this allows me to plop it outside quickly, test it out, make sure it's working, and then bring it back in, because it doesn't make any sense to mount it up on my roof until it's fully debugged. So once I get it fully debugged, the next thing I need to do is mount it outside. Well, it needs to be protected from the rain and the wind and corrosion and vandals. It needs to be up on the highest part of my roof, and it needs to be conformant to local building codes. So it can't be sort of fly by night. It's got to be durable, grounded, well anchored, those kinds of things. And it has to be well grounded, as in I have to drive a ground rod in and then run a grounding cable up to it, and a lot of things that if I was just doing this out in the middle of the woods somewhere, I might not do. Or I might.
But
So
yeah, in Florida, especially here, you need to be contingents for hurricane, for
Yes.
tornadoes, for the county.
Yes, the city of Fort Lauderdale and Broward County in this case. So this is a diagram that I would show the building inspector before I attempt to, I'd ask to see, is there a permit that I need to put this in? I do have to drill a hole through the outside of my house on the wood that's up on the sidewall underneath my eaves, because this goes to the peak of my roof. And there's a roof overhang, that's where it says eave. And this would actually be a heavy pipe. That's the pipe that you see there. That's the kind of pipe that I'm using. So I'll reuse these joints and that flange. So that flange would actually be where the hole goes into the house. And then I have some other sections of pipe that actually extend it upwards. And then I have two heavy gauge metal mast mounts that will anchor on the sidewall of the house and then grab onto the pipe to hold it firmly in place. This is good to 130 mile/hour winds. And you can see that I'll have a ground rod and a lightning dissipator nearby. And then where the wire comes in, there'll be on the Ethernet connection, a surge suppressing and ground connection there before it ever goes onto my home network. Because the last thing I want to do is, for whatever reason, have a ground lightning surge fry electronics in my house, because I've got way too much electronics in my house. I value it too much. But I needed to make a change in how the camera hooks on. The upper picture here is the coupler that's built into the camera itself. You can see the cable going in, and then it just has that metal collar. Well, they only have 3 lightweight screws that screw into that recessed area on the collar, which would not be hurricane sufficient in my book. So what I did was I took a heavy gauge aluminum coupler and I put 3 pop rivets through it. And then I screwed screws in from the outside into that recessed area, and there's 4 of them. And they're stainless steel screws into brass pop rivets into a heavy gauge aluminum coupler. And you can see the size of the threads on there. The pipe is about that big around. But it's very thick aluminum. It's actually what they call IMT, which is heavier gauge than normal conduit. And the only thing that's running in there is that one cable that's as big around as your little finger. It's an outdoor grade Ethernet cable that can run power over Ethernet. But it's also something that if I need to replace the camera or upgrade the camera, it's easy enough to do so by just unscrewing the coupling and then taking the 4 bolts out. And of course, I want to leave it outdoors, so I have to pay attention to things like I need to make it weatherproof and use Teflon tape on all the screw threads and ground it, and maybe consider putting a lightning arrestor nearby. I don't know that I'll put a bird spike on the top of the dome to keep birds from nesting or doing their business on it, because then I couldn't see the zenith. And it needs to be at the apex of my roof towards one end where there's no local trees in the way. And if code
So maybe
enforcement,
later you're gonna buy those little things that you find in car dealers, the little
no, I'm not going to buy an
bird.
inflatable snaky guy. And once I get it in there, if code enforcement comes by and goes, "What's that? Are you spying on your neighbors?" Then I have to explain how it can't get below the horizon and it's elevated. And I don't have a gun in there where I'm shooting down drones or anything. And to avoid it inadvertently seeing a bright sun, I'll park it north to the horizon. So when it's off, it'll face north and it'll be at the horizon, which in my area is pointing at trees. You have to pick your targets. This is not a $1,000 telescope mount with a $700 astro imaging camera. It'll give you 18x optical zoom and 30x digital zoom. So you can forget about the Eagle Nebula and the Pillars of Creation or the Veil Nebula, which you can't see from your house in the city anyway. I know you could do narrowband imaging, but who wants to see the veil in black and white and then have to go process it for hours on end to get color? I like color when I see it. So you can obviously see the moon. It's big and bright. You can see all the brighter planets. I don't know about Uranus and Neptune, but you certainly should be able to see Saturn and Jupiter. Obviously, Venus and Mercury.
So, Monroe,
Yes.
it'd probably be on the next slide, but I can't wait.
Okay.
Now, are you saying that we go through, I mean, there's a lot of things you went through to do this, and you have to contact a lot of people to make sure that you're
Yes.
within, it's a lot. Now,
Yes.
now, could you have gone out and bought them?
No.
No.
If I
Okay.
wanted to do this purpose built for amateur astronomy, it would be $1,000+ mount, and then about a $700+ astro imaging camera. And then if I really wanted to do it up sort of Hubble-esque professional, I'd probably spend another $600 on just software for doing the image processing. But I'm not going to spend that kind of money. I mean, the whole package here is way less than the $700.
Okay.
Remember,
And you're saying it'd be like 3,000 if you went out and just got it already made up.
well, it would
But
certainly be close to 2,000. I don't know about 3,000, but it would be
Okay.
certainly be close to 2,000. And this is
It sounds
probably
like over. Yeah. But then
This
you'd still have to, would it have in the packet that would say contact these
No.
people to let them know? Would you
no.
have to contact
If you went out,
people then?
if you went out there and you spent your $2,000 on your telescope mount and your camera, you would have to set this up every time you wanted to use it, because you can't leave it outside. It's not weatherproof. This you can leave outside because it's weatherproof.
Well, that's a good thing.
Yeah, and you can install it at your house. So where do you go to do your astronomy? In your family room, in your den. Very
In
comfortable.
PJs, dressed in PJs.
Yeah.
No, and the other thing is the instant reward.
Yes.
If you do that, because you can point to whatever's bright and look it up and then see the limits of it later. But, just to be in a presentation like this and be able to just blink, and get the image that you want to do, like you change from your camera,
Yeah.
from the security camera, that was like a blink of an eye. You did that and you could be showing, oh, this is Jupiter, or the sky is good, or there's
Yep.
going to be a meteor shower. This is like instant reward.
Mm-hmm. And
Yeah.
if you,
Now I can
if you,
see Monroe doing it. I
And-
don't know. Maybe everybody else is really on board with all this, but
oh no, I'm not expecting everyone to do this. I've already learned my lesson from my attempt at doing an array of radio astronomy. Not everybody can ride the same tracks that I do. They don't have the money for it. They don't have the technological background for it, and I shouldn't expect them to grow into it overnight, which that was my shortcoming. Was I would say, hey, look, let's go this way. And then I went off running in the distance, and everybody was like, bye. But I understand that. I understand that now.
I just think that it's just a lot of work too. You have a lot of patience.
Oh, it is.
And-
It is,
and
but
a
it
lot-
keeps me off the streets.
Yeah, we don't
And
want
I'm
this man
retired.
on the street. Yeah.
I'm retired. So the idea
Yep.
is you get to watch what I'm doing, go, oh, he's wasting a lot of time on doing that. No. See, when I get it all up and working, then when we have our Saturday night session and somebody says, did you see the moon tonight? It's glorious. Let's go take a look at the moon. And it'll be connected into my home network, and I can just tap into that during the Zoom session.
So you're not really promoting everybody to go out. You're not
No.
promoting people to go out
No.
and do this.
No,
They-
but
we don't really have the. I mean, if I have a telescope,
no,
do I
I'm not.
really mean-
Like I said, I've learned my lesson from the radio telescope array. I'm not expecting everyone to go out and do this. I have no expectation of that. I'm just telling everybody, when I go off and do something like this, and I just show you the end result, and people go, oh, that's interesting. How did you do that? How much did it cost? What are the details? How did you hook it all up? So I'm writing it all down as I do it for two
Oh.
reasons. One is, so if somebody does get interested, it's real easy to reproduce. And so that I don't forget how I did it.
yeah,
So,
yeah. Okay, I just wanted to know if you were thinking that
no,
your audience is.
no,
So
I'm not
you're just
expecting
giving us
everyone
an-
to follow me. I know the way.
Well, I'm thinking you could go out and but you're not wanting, and yours is going to in the end be better than if you went out to buy one
Oh,
anyway,
absolutely.
and you will know it inside and out.
Yes.
And
I'll
that's a
know
good,
every shortcoming that I had to get past, every hurdle I had to cross.
yeah.
But
Quite
here's
amazing.
the other thought. Here's the other thought. Once I get this up and running, how would this compare to those $1,700 automated little telescopes you can buy nowadays? Have you seen those? The computerized little telescopes that are, I think the cheapest one they've got out now is about $1,200. And they're
You
nowhere near
see
as
the
capable as
images on
this.
your phone.
Yeah, they're nowhere near as capable as this.
Okay. My question is to ask how, if you're going to compare it, how would you compare it to the telescopes that are out at Fox Observatory?
They obviously have a larger aperture, but that's about it. As far as the quality of the camera, this is the latest Sony imaging chip. So when they go out and they buy their brand new astronomical purpose camera, oh, it's got the latest Sony imaging chip. It can do 4K pixels. Well, I'm sorry, that's 2 years ago Sony chip. This has the latest Sony chip in it, the one they use in high resolution TV studio cameras, and it can do 8K pixels. So, you know, this is one generation newer than the current astronomical imaging cameras.
Now you mentioned aperture, so that's a drawback?
That's how much light the camera can capture.
So how, what kind of drawback do you have? Because you don't have as much, right?
No, because he just have a camera and not the telescope, because those cameras are behind the larger telescopes. In his case, he's looking directly. The camera has lens mounted on it.
So if this is attached to my house and my house is not in a rural dark area, then what could I see from my house anyway? I'm not going to see those dim deep sky fuzzies from my magnitude 3 sky at my house. So I couldn't benefit from a telescope that is 10 inches or 12 inches in diameter. All I'd get is a lot of light pollution.
So you would not benefit if you had one of those telescopes at your house.
I would benefit from one of these at my house, but the difference between one of these and a 10-inch telescope would be this captures a lot of the celestial objects light. The 10-inch telescope will gather a lot of my neighborhood light pollution.
Which would not help you with doing
telemetry.
Correct,
which is why this is better for home use.
Well, that's sort of like a home. I mean, it doesn't travel anywhere. I mean, you could actually even take that easier to another place than you could take the one that's at the Fox Observatory.
No, that would be awesome to mount one on Big Sky.
What, Helen?
Mount one like this on Big Sky.
At Big Cypress, National Preserve. So one of the things that I've for years tried to work with SFAA and the South Florida Water Management District and the National Park Service is the dark sky sites that we go to have telephony, have data internet access and power access. So once this is operational, why can't they permanently install one of these at those sites? So if somebody said, what's the weather look like right now at Big Cypress, at Seagrape Drive? You could get out on the internet, connect into this thing, and see what the sky looks like right now.
Well, don't they do that on webcams right now, like on the beach? I mean, why wouldn't they use a webcam out there?
Because the webcams aren't designed for astronomy and they don't look up. They're not weatherproof for that.
Okay.
This is.
Okay.
And, you'd want to do the same thing at Harold Campbell, but if you did that at Harold Campbell, you better make it very durable so that the locals don't destroy it.
shooting at it.
I'm sure they'll use it for target practice.
Sure.
I don't know how that happened. The shotgun just went off. Yeah. You see road signs out there with giant holes in the aluminum? It's because they can. So I wouldn't want to put one of these at Harold Campbell because 6 weeks later it would be toast. But putting one at Seagrape Drive at Big Cypress would be very interesting. But first I've got to get it up and operational.
So you are thinking of proposing that? After you
Once I get
this
it
up?
operational, yeah.
All right. All right.
They pay for the hardware and I'll deploy the software, or I'll show their engineers how to deploy the software.
Now, this isn't just going to tell you what the weather's like when you're far away from there. It's also going to help you when you get out there, right?
Yes. But the
Okay.
idea is if you said, what's the weather look like at Seagrape Drive right now? You don't want to know what's the weather forecast. You want to know, if I had my telescope out there right now and I pointed it straight up, what could I see?
Right.
That's what you want to know. You don't want to know the weather report. You'll be able to tell with this thing if it's raining or not, obviously, but you'll also be able to tell if there's cloud cover right now. You'll be able to tell if there's haze right now. So
Now, if they
yeah.
attach something like your telescope or your camera to the outside, you'd actually be able to see the stars and whatnot, even from your home.
Yeah, I could do that. I could make it where it's internet accessible. I wouldn't want the telescope mount controls and camera controls to be internet accessible unless I put them behind a password and just, set up some scheduling program for people to use it.
That would be sort of neat because that's what they do with Peru and the other places. I get the
I
Canary
know.
Island or something. And you can get time on.
I know. I'm familiar with SLU. Yeah, I'm familiar with SLU.
Yeah.
So
And I
how's
like
SLU working with that volcano?
Yeah.
Remember, SLU had a telescope at the observatory where they have the volcano right now.
Oh no, I didn't realize that.
Yeah. So I'm
that in
wondering if
Peru?
that SLU observatory is still open right now.
I
So
did
if
that
you
for
were
2
comparing
years,
this, if you were comparing this to I've got as deep a wallet as I want to, how would you say, what's the shortcomings? Well, you can't do multiple second exposures. The most you can get out of this is 1/4 of a second until they realize these are used for astronomy purposes. And they say, oh, well, it's just a software change to make it where whatever exposure duration you want, you can get. But you can still do, grab images and do video stacking if you want to. There's no Peltier electronic cooling of the chip. So there's a minimal darkness that it can go to before it starts getting electronic heat noise. There's no ability to go, I really need a lot more magnification tonight. How do I screw on a Barlow lens? You can't do that. But then again, if you were looking for the same capability you had for $1,000+ telescope with a $700+ camera, you're not going to get that. Because first of all, you're not paying $1,700+. Second of all, the imaging setup time is nil on this once you get it up and running. But, if you've got an impulse viewing session, you can throw this up on the big screen at your house. And it's going to be under $650 total for everything, which is less than just the camera. The idea
we're
is
in Florida. We're in Florida. So, I mean, most of these places that go to great lengths to see deep space, they're in the mountains, right?
yes, the big observatories are at dark sites, which means they're elevated on mountains. They're in very rural areas, or they're inside of a ridge of mountains where they're secluded. And they have local government ordinances that say, you don't get to put out your big bright white lights.
Too bad we can't do that around here.
Yeah, wouldn't that be nice? Helen and I have been to the Dark Sky Festival up in just south of Orlando. And it was very comical because they called it the Dark Sky Festival. And they had to literally go out and tape red plastic onto all the street lights in the parking lot because they were the most god-awful bright white LED maximum luminaries you could have. And by the end of the evening, it was melting the plastic.
Oh boy.
But that
Now,
was their
this was-
dark sky festival.
Was it shining up into the sky also?
These white LED lights in the parking lot were so bright, they were reflecting light up off the black asphalt.
Okay. And they
So
were
they
also
were-
shining from their, I mean, did they have the cover over the top of them at least?
No, they were facing down and they were full cutoff. So they thought they were wonderful lights. But there
Yeah.
was so much light coming out of them and it was so bright white. It was like 10,000 plus Kelvin white. And they were putting the most chips they could put in each one of the lights, that the amount of light coming out of them was so bright, it was reflecting off of the pavement asphalt upwards.
Yeah. Making it look like it was daytime out there.
Yes, literally.
Yes, it was.
And then just to add insult to injury, they had so many cars that the parking lot was overflowed out into a large grassy area. So to make it comfortable for all the people that were coming for the Dark Sky Festival, they went out and they got diesel generator powered floodlights and put them all over the parking lot.
Yeah.
So it was
Yeah.
not dark.
It was this is anything but Dark Sky Festival.
Yeah.
But we couldn't see the Milky Way.
Right. You couldn't see the Milky Way naked eye. And that's what you go to a Dark Sky Festival for. It's just what people think versus reality.
So people who
Or
live
maybe
there,
as a safety issue.
people who live there outside of the festival, the everyday people there, they probably could see the Milky Way when they, leave the house and look up. But
Yeah.
during the Dark Sky Festival was impossible.
Even with their red light covered melting filters, because of the parking lot diesel generator lights out in the field, they just had them flooding the area with light.
A shame. A shame. I'm sure that the festival didn't go as well as they wanted then.
It's
The-
because
the-
when you contract someone to promote your event, do your event, these people know about the rules of the city, the what kind of license, what kind of this. They don't know about astronomy, so it's like it's what Monroe says is a failure to communicate.
Yes. Our
Yes.
first indication that this might not be what you think it is when we drove into the subdivision, we were not allowed to drive through the shortest distance to where we were going to park. We had to come in through the far end of the subdivision and drive this coned off snaky path past all the houses that were up for sale. The event was actually promoted by the local real estate office. So once they
boy.
sold out all the properties in the area, the Dark Sky Festival ended. So they don't have it
Oh
anymore.
no.
Yes.
Oh.
It was this rural neighborhood that they couldn't sell the houses because it was too rural out in the middle of nowhere. It was dark. And somebody said, why don't you have a dark sky festival? Because the astronomers love dark areas. And so the place started to grow out and they put in this little shopping center and it had a brand new paved parking lot for people to park to go to the shopping center. And the parking lot had lots of really bright white parking lot lights and had a fresh coat of asphalt covering the parking lot. And it was very reflective of the bright lights. So they had the Dark Sky Festival in what they thought started as a dark area, but was no longer dark and was never going to be dark again.
Wow.
But once they sold all the homes they were going to sell, the backing by the real estate
Well,
company fell
suckers.
away and no more event.
Well, you didn't like it there anyway, right? It didn't work.
If I was there the very first year they had it, it would have been much better because that shopping center didn't exist. The bright white parking lot lights wouldn't have been there. And because there would be a lot fewer people there, if we had to park on the grass, they wouldn't have sprung for the diesel generator lights.
Right. But the event got canceled once they sold to all the homes, and as you say, the
Yep.
parking lot will always be light again.
Yep.
And so the event to continue there would make no sense.
Yes, it outgrew its usefulness.
Yeah. In both ways. I mean, it wasn't just, I mean, even if the salespeople, the real estate people still wanted to have the event for whatever reason, it wouldn't have drawn people like you to go there. You'd
Oh,
say,
I wouldn't go
"I'm
back.
not
No,
going
I wouldn't
there."
go back. No.
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 So there would be no reason to still have it.
Well,
So,
sometimes it's simply a matter of the person who promotes the event has the motivation and the stamina to do it. And once they leave that role within a government authority, the event falls through. Palm Beach County used to have a dark sky event, and the one woman that ran the show coordinated everything. And it was really great. And it got bigger and bigger and bigger. And then she got a job elsewhere, and it just kicked the legs out from underneath the event because nobody knew how to do what she did. And it went away. So I understand how these things happen.
yeah. And sometimes whatever you're doing just doesn't attract people anymore, though, too.
Well,
And
I
when
mean,
detracted,
you can have the area grow up around you. There's a place in Florida called Chiefland that they had a Chiefland dark sky event once or twice a year because it was really dark there. And it was a rural neighborhood, a lot of, multiple acre homes, and people had built their own observatories there. But the local cities grew up around Chiefland to the point where they were so bright, Chiefland no longer had skies that were anywhere near as dark as they used to be. But people still had spent, tens of thousands of dollars on their home observatories there, and they bought property there, so they're kind of stuck there. So
Oh, boy.
instead of doing full color imaging, they're now doing narrow band imaging and shooting lots of exposures to create false color.
oh, well, that,
But it's what they bought into. It's what they've got. It's what they have to work with. And the local cities that are growing like wildfire are not about to suddenly dim down because people get scared of the dark.
yeah, that's true.
There's so much light in my neighborhood. If I have to go out and take out the trash cans on a Sunday night for Monday morning pickup, I don't bother carrying any light with me because it's so lit up. I can see everything, but my house has red lights on it. So I can see in the red lights, but there's so many white coach lights with, open exposed filaments that are just white glaring off the front of the houses that the whole neighborhood's illuminated. And if that's not enough, then Calvary Chapel over, 5 minutes from my house has these stadium lights that are higher than the tree surrounding. So I always know when they're going to play a game at the stadium over there because from my house, I can look over and actually see the stadium lights. Now, why would I need to see photons that they're spending money to generate to illuminate the field? Because they don't think about things like that. They just think about how bright can we make the lights? We want our teenagers to be safe.
Is that why the sky, there was a planetarium across the street from where Vizcaya is or near there? And you guys said you went down there and it wasn't there anymore. Did they move it somewhere else, the planetarium?
That's purely a matter of money and government.
So it wasn't anything to do with lighting.
Yes, the Miami Science Museum was down there. It was created on property that was owned by the Vizcaya Estate Trust, and they had a limited term contract. And rather than renew the contract, they worked with local private funding and local community funding, City of Miami and Miami-Dade County, to build a brand new science museum and planetarium, maybe not observatory. So they built one, and they built one on Biscayne Boulevard in downtown Miami. So it is a large, very new museum. They buy their exhibits. So there's not a lot of locally created content there. They have an aquarium that is too small for all the life that they have living in it. And the life
Oh,
go
no.
crazy. It's the biggest part of the tank is large and it's round. And they literally have aquatic creatures that are chasing each other in circles around the outside perimeter of the tank. So
Does not sound like some place that's great to go to then.
we went there, but unless something very interesting comes up, I doubt we'd go back there again. The planetarium that they had at the old museum was a complete dome. One of
Yes.
the things that's nice about a full dome planetarium, it's actually a hemisphere, it's not full, it's a half a dome. One of the nice things about that is if you're sitting in your chair and you can look up and somebody says, you're facing west, and this is rising on the horizon in the west, and now look off to the south. You would look to your left 90 degrees and you would see south. But the only way you can do that is if you have a hemispherical dome, because then you can have the seats in one place. You look up, you can see the sky, and you'll be facing to the west. And so if you want to look to the east, you look behind you. And if you want to look to the south, you look to your left, the north, you look to the right. But when they built the new planetarium, they did not build a full hemisphere. That would have cost money, and that doesn't work well for IMAX theaters. So they built this orange peel slice, kind of like an orange wedge projection screen. So when they want to show you the south is here, the north is here, the west is there. And they flip the image to show you the east. That's not real astronomy, because you're always sitting in your chair looking in the same direction. You don't get the feeling of compass direction. Which way am I looking?
Yeah.
But the most distressful thing that we found when we were in the planetarium was we had some time to talk to the young professional planetarium operator. And so I asked him a few things about the capabilities of the projection dome that they had. It's an 8K capable projector, one projector that can produce, an 8 megapixel image. Very great. And I said, do you run Stellarium? Oh yeah, I can run the Stellarium software and do all kinds of simulations. Great. Why don't you do shows based upon that? They won't let him. In fact, they were kind of down on him telling me that they can do that. They buy packaged shows and will not let him change them. So they're showing these like really low level beginner, like basic stuff, and nothing that would attract inquisitive mind. But that's because it's really meant to be an IMAX theater, and they want to show you the latest superhero movie there that's going to make rumbly sounds.
Mm.
But when their programs are bought in and not allowed to be modified, when their exhibits are traveling rental exhibits and they get them on the third run and they're damaged and half the stuff's not working and they don't bother fixing them, it's just distressing. And they have a few science labs there where the local high schools and the local college can have students that learn some scientific procedures there. But they get, the museum gets paid for those. So it's, and you have big name companies that want to go and show you things like there's a medical facility nearby and they paid to have an exhibit in the museum, and it shows exactly what they want and nothing more. And you go there and there's all kinds of promotional splash ads and signage for that medical facility. But when you go look at the actual exhibits, they're really simplistic. There's not a lot of thought that is going to inspire youngsters. But where it did, Helen and I spent a lot of time looking at this one illuminated thing where you can walk out on this floor and the floor would change colors and patterns based upon where you were stepping. And it took us a while to figure out they had a camera on you and they were watching where your feet were moving to know how to make the image change. Fairly simple, but the kids loved it because they could jump all over the floor and exercise, and things would change when they jumped on it. And The lights would change and the sounds would change. It was very entertaining for the kids, but they weren't really learning anything from it. But I don't run that place, so they can do whatever they want to do.
True.
Yeah. But the
But it does
distressing part,
help
the
to know.
distressing part was the foundation that provided the money to get them up and running and then decides what they're going to be showing. That's a group of people that are not enamored with evolution. And they don't like it when you say billions of years old. So you won't find a lot of like Big Bang kind of things there.
They did have Big Bang at the other one, and they did have
Yes.
a big bear there.
Yes.
I love that bear.
Yep. Well, even that's changed. The Museum of Discovery and Science in downtown Fort Lauderdale, they used to rotate through young museum professional wannabes, career starters, and they would be very enthusiastic about doing things and showing things. And when COVID came through and they shut down the museum for a while, that just kind of stopped. And now all they do is they do what my museum does, is they rent traveling exhibits. Maybe things will come back in
changed
the
a lot
future.
of things. COVID
Maybe.
changed a lot of stuff.
Yeah, well, they found how little they need to actually spend to keep an audience. And they're staying at that low bar.
Well, it's a low bar because right now people are not competing with entertainment. Has been
Right.
very little. But once they get a lot of other things attracting them, maybe they will once again see that there's
Right.
competition.
Well, Helen and I were at this event last night, and there was probably 150 people there, tops. That venue is supposed to be able to support 500 people. Now, that's ignoring any COVID restrictions, because once you throw in the COVID restrictions, they were limited to 250 people. So even if people wanted to come out, once it got too packed together, the local event management would have, I won't say ran people off, but would have found a way to curtail the crowd density.
So what was this event? I know Helen mentioned it earlier. I forgot what it
It
was.
was just a band shell open music event.
Oh, a music
They
event.
they had some trinket vendors there. You can go buy jewelry and candles and dog food and dresses and pictures.
Dog-
Yeah, the artisan dog food. If you don't want to go buy a box of milk bones for your dog because your dog's better than that, you can go buy the $12 small plastic bag of little biscuits that, those are fully organic and homemade, and that's better for my dog. $12, please.
Yep.
That's
Do you
just
have a
what people
dog?
do.
Thank you for going over that with me.
Well, I also found out what those vendors pay. We've been to events where you pay $50, $75, or $100, and you would get a 10 by 10 pop-up tent, and then you could do your exhibit there and done. And they would set up the tent, and at the end, you would just fold up your table and go away, and they would take the tents down. And what I found out in reading about this particular event is you pay $75 and you are required to provide a 10 by 10 white pop-up tent. They don't provide it. You're required to provide it. Has to be white. No black ones. No white tops with black frames. It's got to be white frames and white tops. And the dirt bags that weight bags on the bottom to hold them down in the case of wind, you have to get bags to their specifications. So they have to be biodegradable fiberglass bags full of beach sand. And you were required.
I saw one of the tents have like those exercise weights, like iron discs.
They were not to spec.
Okay.
I read the actual vendor registration website, and I was thinking $75 they're going to put up a tent. No, they're not going to put up the tent. You have to put up the tent, and they're going to tell you what kind of tent you can have. Oh, well, your tent must have weights on its legs, and they're going to tell you what kind of weights you're allowed to have. Oh, your table. You can have a table up to a certain size, and the cloth covering on your table must be linen to their specifications, and it must be white. So there's just way too many things that I would ever want to be a vendor there. Plus, in order for them to be in good steads with the state of Florida, your organization, even if it's a nonprofit, must have a state of Florida sales tax license, which SFAA never had one of those because we went to nonprofit events where that wasn't required. And if it was required, we chose not to sell anything. We could give away things. We chose not to sell anything and not to require any donations. So you got to dig below the surface at these events to find out what's the total cost of being there. What's the expectation for selling or offering information? And sometimes it's, you can't give handouts because handouts become litter, and they don't like littering. So you have to pay attention to all of this. So anyway, getting back to the camera, the downsides are you can't do multiple second exposures, but you can do capturing of images and then video stacking. You can still do that. There's no electronic cooling of the circuitry. So there's no Peltier for doing, but then you can't do multiple second exposures anyway, so it's not an issue. But there's no ability to like screw on a Barlow lens to get 4x or 5x magnification because it's fixed inside the dome, inside the glass dome. So if you're looking for something that's $1,000+ telescope mount with a $700+ astronomical camera with a Peltier cooler, this is not it. You'll likely be disappointed. But if you're looking for something where you can go, I wonder what's up tonight, and you can just turn it on, point at it, and look, and the total thing costs you under $650 for full deployment, this might satisfy your expectations. So the current stumbling blocks I have is the infrared LEDs. I'm finding it difficult to turn them off. And I've read the manual, I've read the technical manual, and it says, just do this, and the LEDs won't come on. They still come on. So I think it's a software conformance issue, but most of the people that use these for surveillance, oh, they want those LEDs on. That's how they see in the dark. I'm putting a glass dome over it. You turn the LEDs on, they reflect inside the dome, and it messes up the image. The second thing is there's a feature where I can turn off the autofocus on zooming, but it still seems to do autofocusing. So once again, it's for surveillance, this is good. For astronomy, this is not good because I'm zooming out at something that's like Saturn. And I don't want to go zooming back and forth trying to autofocus it. I want to zoom out as far as you can go, and then I will tweak the focus electronically, and then I want it to stay there. I don't care if the sky distorts and that comes in and out of focus, but I don't want it to chase the image.
Do you have access to the LEDs where you can put duct tape over them?
These are very powerful LEDs. I put black plastic tape over them. It literally got so hot it wanted to melt the tape. I 3D printed some little black discs, and the little black discs I thought were like 0.1 millimeter webbing on the filament, and it's still, the lights are so bright you could see red light coming through the filament. So it'd be much better if I could get the manufacturer to say, okay, here's the new software. It actually obeys the documented interface so you can turn the LEDs off. I would prefer that.
Yeah.
I've sent them an email. It's been over a month. I'm gonna have to ping them again. Maybe I'll go out on the Amazon review site and say, I'd really like to repurpose this for astronomy, but you need to fix the illumination software interface where it actually does what it says it does, and you need to fix the autofocus where if it's disabled, it's really disabled. But they're probably going to say, I don't know, works for everybody else. Yeah. So I have to write these two drivers, one for the telescope mount, one for the imaging. I started writing the code, but I've been frying other fish, as the saying goes. But in the interim, I can, just to make sure the camera is working and play around with it, I can run it on its test post and use it through its web interface. And when I'm not trying to run Zoom at the same time, I'm thinking it'll be a little faster. So in the interim, I've removed the glass dome and I set it outside when I want to play with it and just grab it and bring it inside. But there's not a lot of setup with that. But at the moment, without the glass dome, I can't leave it outdoors. And I have a slide. The slide is for pudding, as in proof is in the pudding. But since I don't have any good images to show yet, no pudding yet.
So you could put out there, you cut this that I'm talking now and then you speak again just to put on the video. You could put it out there if it's anyone who sees the video on YouTube that wants to help up with, some of those ideas. You could ask about programming or interface or knowing the ship and how to reprogram.
Well, if you remember the early days of this YouTube site, Jay Messeroff would come online and provide us with current views from his telescope setup at his house. I don't know why, but he suddenly just went radio silent on us. I don't know if he's found other things that he's working on. We took up 3 hours of his time every Saturday night, and maybe that was too much. I don't know. Not
Did he
everyone's
belong to other
cup of tea.
clubs? He
What
belonged
was
to other
that?
clubs. He belonged to other clubs.
Yes, he belongs to multiple other clubs,
Yeah.
but he's in the
Yes, he
Charleston,
does.
South Carolina area.
Whatever happened to Jack? Jack Pfister?
I see him. I'm still following him on Facebook. He'll put postings out there. I think he's doing a lot of kayak trips. So he's having retirement fun. He and the wife.
He's a
The last
character.
time that I saw pictures of him, he was kayaking and going to lakes and walking
Yeah.
and doing.
There was a
He's
smile on his
living the
face,
life.
so he's happy doing what he's doing.
He's living the life.
Yeah.
Yeah, I miss him,
When the weather starts to get like cold, he will be back.
I think you're right there. I think they both might be like, what's going up with the Brown Astronomy folks? It's too cold outside. It's totally overcast. It's rainy. We're the foul weather friends.
Yes.
Yeah.
It's half past October in New Jersey. It must be getting cold.
But he's not in New Jersey. He's somewhere like maybe in a park or something. Because I've seen pictures
Oh.
of him like in nature and with
Oh, wow.
kayaks and fishing.
Yep.
He's
They'll
living the
be
best
back.
life.
They'll be back when they miss us. So in
So
conclusion,
when you finish your conclusion, you ask for the people who had the patience to watch the video to if they want to have like ideas or suggestions or something like that.
yes, I will get to that momentarily. So in conclusion, if you're an amateur or a novice astronomer and you're interested in doing live observing and you're not interested in winning the next astronomy picture of the day kind of thing, or getting magazine articles or pictures or catalog pictures, then this could be something that you might want to take a look at, but you're not required. If your goal is high-end astronomy and you have thousands of dollars disposable income you can spend on equipment and software, and you have no objections sitting in the dark of the Everglades in the heat and the mosquitoes, and then bringing your images home and spending hours post-processing them in the computer, and then false coloring them and touching them up, and in order to attain a single Hubble-esque like image that everyone else has gotten the same image, then this is probably not what you're looking for. I've watched many people hone their astrophotography skills, and the number of times I've seen, this is my first picture of the Orion Nebula. What do you think? It looks like pretty much everybody's first picture of the Orion Nebula. And then if they stay with it, the one that they take 2 years later looks oh, magnificent, looks far better. But you don't want to tell them that when they took their first pride and joy picture. I understand that. Anyway, any comments or questions about the surveillance camera turned astronomy camera?
Now, my only comment that if works, that would be awesome because it's simple to use. And when you show things to people, especially online, that is an awesome solution. I really like the idea.
Well, once it's operational with the likes of Stellarium through Indy, it proves that it's something that's doable. If because a lot of the astronomy cameras are nothing more than repurposed webcams. They're not even like really high-end digital cameras until you get to about $3,000 for the camera. And then they're purpose-built cameras. But any astronomy camera that you pay less than $1,000 for is nothing more than a redesign of a web camera. And you can get those at the $100 level, $300 level, $400 level, 500, 700 starts to get a little more serious, but they don't redesign from scratch until you get to 1,000, because when you're buying camera chips in small quantity, the chip itself is going to cost $200-300. That's how Sony charges them out. But if you want to follow the trailing edge of cheap technology and you want to say, well, if I use the camera chip that was in last year's or maybe 2 years ago iPhone, I can get that chip for $20. And I can put that in a $300 astronomy camera, and most people will be satisfied with it. But then if you want a Peltier cooler on it to make the image even better, that'll be a $700 camera. But the Peltier chip is only $20. Oh, because I saw you coming. I saw your wallet in advance. Yeah, okay, I get it. So I understand how there's the gray market that buys up surplus chips from 2 generations ago to make things more reasonably priced. And then there's, well, why don't you find the product that's already using the new bleeding edge chip, and they're producing it in quantities of millions, and therefore their product price is going to be low because they're not buying 100 chips from Sony at a time. They're buying 500,000 chips from Sony at a time. So they're going to get the reduced chip cost right out of the gate. So if instead of building your own camera, you take one of the cameras they built and you change it. And I saw this years ago. Somebody took a high-end web camera and they learned how the software operated on the inside of it, and they reinvented new software to run on the same camera, and you would basically overwrite the flash storage of the firmware for the camera that you bought it as, and you would load the astronomy purpose camera software onto it, and it would be a really nice camera. But you had to be able to control things like the exposure duration in software. It couldn't be a part of the hardware of the chip. So you have to have the right parts on the inside before you start attacking it and repurposing it. And that's why it's better to spend my time and my money doing that than it is to lead anybody down a dead end and we find out, oh, I'd really like to do 3-second exposures, but the chip won't let you.
I guess it's bewitching hour.
I'm guessing we're past it.
Yes, we are.
Yes, we're an hour and a half past it.
It's after midnight. Holy cow.
It's after 1.
Yeah.
Thanks everybody for sticking out through the first 45 minutes of me playing with the web interface to the camera.